Okay, so keep going. So
Okay.
from 8 to 80 is a factor of 10. So that's how many dB?
That would be 10,
Yep. And then from 80 to 800,
80 to 800.
another factor of 10.
Oh, okay.
What'd you get? So that's another 10 dB. Add them up.
369. I have 29.
Yep,
Oh,
that's it.
wow.
That's how you do it.
Oh, okay. So that's why I was getting confused.
Congratulations. And now you drove through it yourself.
Okay, great. Thanks for your help. I was
Okay.
couldn't
Yeah.
get it.
Kent, I see Kent. Say hi, Kent. If you're here,
Hi, good
Kent.
morning. Good morning. Good morning. Good morning, everyone.
Morning.
Scott, I'm sorry to jump in here.
Yeah.
Is Christopher Fink going through your class?
Uh, that's a good question. I don't know that I have seen or not seen. And there are some people who are doing it, now that we have college classes that are asynchronous, there are some people who are doing it a little asynchronously, like doing it at night. So I don't 100% know.
Okay. All right. I'm trying to track this guy down. Yeah. All right. Let me get out of your hair. He's somebody who's registered, partially registered for an exam. And
Okay.
um,
Do you have his
trying to,
phone? Do you have his phone number and email and stuff?
I do, but it's not
Okay.
going anywhere. So
Oh,
I'll handle it. Thanks. I just thought he might be here.
okay.
All right. You guys, good luck. We'll see you tomorrow. Any questions for Kent before he leaves?
Did I get everything in that you needed, Ken?
There are 40 people on here, and I don't know who I
That
is.
was Snow.
Yes,
Yes.
yes.
Okay. Perfect. I wasn't sure. It kept erroring.
He's driving.
I don't recognize this. Don't recognize this. So I just went.
All right. I think we're good. Kent, we're good.
Okay.
But,
See ya.
but,
Thanks for throwing the barge in.
weather up there.
Yeah.
Yeah. All right.
Would
You
this
don't,
be
you
an
don't,
okay
you don't,
time to,
what?
excuse
Go
me,
ahead.
would this be an okay time to say that Amanda Johnson is going to decline from taking her test tomorrow?
Yes, it's a great time to do that.
Okay, perfect.
Kent, you get that?
Amanda Johnson.
Yes.
Okay.
Is she on your list?
I don't know. I've got to go look at it.
Okay.
All right. Thanks for the info. Appreciate it.
And I'm not going to be taking the test tomorrow either.
Tina Stone.
Hey, Tina. Okay. Amanda and Tina, did you both register to take the exams?
Yes. Yeah.
Not for tomorrow, but yes.
Right.
Oh, so you registered, but not for tomorrow. Then you're fine.
Okay.
We're
Yeah,
just
I'm
talking
doing
about
mine in
anyone.
February.
Yeah, we're just
Okay.
talking about anyone who didn't who registered for tomorrow and changed their mind. So
Yeah. Then after today's class, I'll let you know for sure if Francie, that's me, will going to take the test. I just want to see how I do today, and then
Yeah.
I'll let you know for sure for
Yeah.
about tomorrow.
Amanda
Okay,
Johnson, right?
thank you.
Amanda Johnson, right?
Yeah, and it's spelled JonSson. There's no H.
Yeah.
Johnson.
Yeah, Amanda, you're not registered to test.
Oh, I thought we both were.
And Tina, what was Tina's last name?
Stone.
Don't, but
Yeah.
but don't worry, because she's not on today. She's not on this list anyway.
All right, Amanda, you're not registered with us either. So
not a concern.
Then okay.
But now, because signing up for the class is not the same as signing up for the exam.
Right.
So
yeah, well, we thought we signed both of us up for both the test and the class when we signed up. So we might have made an error.
Yeah, well, when you go through the sign up for the exam, it's a much more complicated process than just sending me an email. And that it's in that really long email that I send everybody. That you have to go through that really long email.
Yeah, well, I thought we did.
Can Okay, so
The ease,
Scott, if I may, just one
Please.
thing.
Yeah.
If you're gonna register to take the examination, there are 3 steps you have to accomplish. 1, you'll register on the examination platform. 2, you will pay your fee. And 3, you will complete the examination agreement form. If you don't do those 3 things, you won't be registered to test. Okay, so all of that information's in Scott's email, but I just distilled it down to the 3 steps that you have to do, okay?
Okay,
All right,
thank you so much.
thank you. All right,
Well,
Scott,
and
sorry,
you
sorry to
get an
barge in
email
here.
confirmation for each of those.
Yeah, you do. So I mean, it's
And
a
for
much
those
more
that didn't,
yeah, it's a much more involved
You,
process.
you get an FCC email, you get an exam tools email, you get a receipt from Anchorage Amateur.
and for those that didn't, can they still follow that same link to schedule for a future test?
Yes. No, it's
No.
a different. Yeah, you just go to Anchorage ARCVEC and you just
Here,
schedule.
I'll drop a link. Scott, I'll just drop a link in chat for folks who want to test at a different time with
Yeah.
us. I'll put that in the chat here. I'll get it for you, so you don't have to go through this. It'll make it easier.
And as far as seeing who's on the list, it's a big list. It'll take a long time to read it. If you have a specific question as to whether or not you're signed up, this is a good time to ask because Kent has the list handy.
I was gonna say the easiest way to say is, did you pay your $10? If you didn't, then you didn't sign up.
I've got 30 people scheduled to test so far.
Okay. Can you email me that list? If you could?
Yeah, you can see it yourself also, Scott.
Oh, do I go through yeah,
Yeah,
okay.
just go onto exam tools. you'll
Exam
see it.
tools. Yeah, okay.
Yeah.
Okay. All right. Let's get through all this stuff today, shall we, everybody?
See ya. I'll
Thanks,
just
Kent.
drop it in the chat. I'll be quiet. See
Okay.
ya.
All right. We've got a lot of work to do here today, people. So what we're going to start with today is, oh, by the way, good morning to everyone. And you've survived the first 2 days. So kudos to all of you for doing that. So let's see, we did grounding, we did RF exposure and radiation hazards, setup and operating controls. Okay, so first thing we're going to do, since remember, everybody now here is an expert at Ohm's law, and everyone's an expert at figuring out what frequency and wavelength are. So that's great. The first thing we're going to do is talk about hooking up a station. So this is really station building. Notice station setup and operating controls. So, okay, in order to hook up a station, you really have a couple of basic components, because most radios most electronics do not work on AC, they work on DC. You need a power supply. Power supply converts AC to DC. Plugs into the wall. Maybe it's built into your radio. Sometimes it's not. Sometimes you don't have a power supply, you just have a charger. But either way, you end up with DC. Then you have your transceiver, which is a mix of the words transmitter and receiver. From there, you go to, if it's an HF radio, you have an antenna tuner. If it's a VHF handheld, you typically do not have any kind of tuner at all. This goes through feed line up to your antenna, which could be as simple as a rubber duck antenna that's attached to the radio. It could also be something that's 100 feet tall out in your yard, like in my case. This right here is coaxial cable. It could also be ladder line. Ladder line is basically, instead of being cylindrical cable that looks like this, ladder line is basically this and this, separated by space. That works well too, but it's open. So what ends up happening is, if it's raining, this can collect water, and that changes the characteristic impedance a little bit, so your antenna can detune slightly. So why would you use this? This is kind of lossy, especially at higher frequencies. This is low loss, but it's a little harder to work with because you can't lay it on the ground, And again, when it gets wet, it acts a little bit weird. If you live in Oregon, that means it acts weird a lot. Okay, so if we're talking about power supplies, we're going to do an Ohm's law calculation here. The Ohm's law calculation is that we're going to have, here's our two lines. We're going to have our plus and our minus out of our power supply going to our radio, which is the 12 volts, and it's going to pull 10 amps. This cable has a resistance of 1 ohm. Okay, if we now have 10 amps going through a 1 ohm resistor, what is the voltage that is lost in this cable? Somebody tell me what formula we're going to use.
I times R equals E.
E equals I times R. Okay. So, which is E is equal to 10 amps times 1 ohm, which is 10 volts. Okay. Well, our power supply is 12 volts. We have now lost 10 volts going just through the cable. How much
2 volts.
voltage is left to run the equipment?
Goes. Or 2.
2 volts. Okay. What will happen to your equipment if you try to run it on 2 volts? And it's a 12 volt piece of equipment? Nothing. So your thing will not work. So this is called voltage drop. And we try to minimize our voltage drop. So the one thing that we can control, well, if we look at our cable, one thing that we can do to reduce our voltage drop is instead of having a cable that is this long, we can have a cable that's that long, right? We could also take a cable that is this thick and replace it with a cable that's this thick. These are ways to reduce our voltage loss, voltage drop. So what we do is we get beefy cables, sometimes ridiculously beefy looking cables, and we make them as short as possible. That might mean trimming 10 feet off of an extra long cable that somebody gave you, but that's okay. You can always go get another one. Okay, back to this. Here we go. Okay, so a typical 50-watt transmitter at 12 amps. Okay, you'll probably see something like this. It'll be a 50-watt radio. Okay, this could be a 50-watt anything. Doesn't even have to be a radio. So we have a 50-watt radio. What formula do we use to figure out to relate power to voltage and current? Everybody, you're going to have to know this like the back of your hand.
P
P equals I times E. Okay. And we have 50 watts. Wattage is also a measure of power. So we know our power. We know that our radio is 12 volts. So we don't know our current. So I is equal to P divided by E equal to 50 divided by 12, which is about 4.2 amps. This is clearly not the correct answer. Why is this not the correct answer? Somebody give me some reasons why this is not the correct answer. Come on, it's not that
It's
early.
not
We've got lots of
efficiency.
creativity.
It's not accounting for loss.
It's not accounting for losses. It's not accounting for the fact that transistors, amplifiers are only about 50 to 60% efficient. It's not accounting for the fact that, do you have a digital display? Does it have a backlight? Is it lit up?
and SWR.
Potentially SWR. Although not so much SWR, but you've got backlighting. Is there a microprocessor running the radio? Probably. Anytime you have a computer, it uses power. So the good rule of thumb is that you typically need about twice the amount of power to run a piece of equipment as the output power is. So for this, we determined that the actual power, the actual current consumption would be 4.2 amps. What that means is I would go for at least 10 amps. And usually we give yourself a little bit of headroom and you go with 12 amps. And that's how we get that. And that is due to the efficiency of the radio, efficiency of the transmitter, and all the electronics. Okay. Okay, now another thing that we do, and actually I'm going to take this opportunity to share this. Okay, so right now, this is what my receiver up in my shack, which is in the garage, is hearing on the 10-meter band. This is being done by software that is listening. So obviously, somehow this software must be interfacing with my computer. And in fact, not only is the software interfacing with my computer, but if anybody can see my phone screen right here, my phone is interfacing with my computer, which is sitting in another room in the house. So I am actually remote controlling my station from my phone. So there's all kinds of cool stuff we can do with this. Let's see, we'll go back to this, go back to here.
I have a quick question, right quick.
Uh-huh.
You said that you're running it all from your phone.
Yep.
And I'm curious to know, in a SHTF situation, how would you do that?
The phone wouldn't work.
Right, but
Yeah. Well,
everything else-
the only reason I happen to be running it from my phone is because I can. I mean, this
Oh.
is out of convenience right now because I happen to want to be doing that. And
So would you suggest solar for all of that? Because
solar
it's a lot
powers?
of power, right?
No, well, it depends. It depends how much power you see, and this is part of knowing what it is that you're trying to do.
Stop
Is a 100-watt panel adequate for charging batteries? And the answer is it depends what size batteries you're running. It depends whether or not somebody wants to power other things in the house.
Or region of the states you're in.
Yeah, state you're in, whether or not it's a northern or southern, what the incident sunlight is, how long the sun is shining.
So that is not a definitive.
Nope.
You'd have to factor in all of those things to figure it out for yourself, right?
Yep.
Just curious.
But think of all the cool tools that you now have in order to do that, right?
Yes.
Okay. Okay, so let's see. Interfacing a radio to a computer, which you may someday want to do. Okay, so if you think about, here's our radio, which I'm going to put by marked by XCVR. There's an antenna hooked up to the radio. Coming out of the radio is audio. Normally this would go to a speaker or something. Instead of going to a speaker, though, we're going to take this audio and move it somewhere else. We are going to move it to a computer. And there's something called a line in on the computer. We're going to take the audio out. So this is the speaker plug or speaker jack on the radio. We're going to run it to the line in. And then the computer also has a speaker port. And we're going to take that and run that into the microphone port on the radio. Now, the other thing, so that takes care of the audio. The other thing that we have to do is we have to have some way to switch the radio from receive to transmit. That's known as the push to talk line, PTT. And that's just a line that switches open or closed. So this is how you interface a radio to a computer. People have been doing it for the last, I don't know, 50 years in one form or another. Not necessarily to a computer, but I guess probably 35 years to a computer and 50, 60, 70 years to telephone lines.
You're talking about
years.
packet radio?
Yeah. Packet, any digital mode for that matter. Now, one thing that makes this convenient in today's world is that a lot of radios actually have a sound card built in. So you hook up a USB cable and it takes care of all of those. Makes it a lot easier. Okay. Next. How do you connect it? Audio and input. Okay, we already kind of talked to that. So line in, line out. We talked to that. Okay. Now, we're going to talk about ferrites. Okay, a ferrite is a material that constrains magnetic fields really well. And when I say that, I mean quite literally, it constrains magnetic fields. So we're going to have a piece of wire, and we're going to have a current flowing on the wire, and it's going to be oscillating back and forth. Well, from now we'll do it this way. It'll magnetic field will be going this way, and then we're going to reverse the direction, and then the magnetic field will be switching back this way. Either way, it's kind of a mess because there's a magnetic field floating around. Now, let's say that there is this magnetic field floating around, and there's AC and DC. Well, the DC will make a continuous magnetic field going in one direction. The AC will make a magnetic field that oscillates back and forth. And what we can do with this is we can use a piece of some kind of magic material, which has a property such that it will constrain magnetic fields. And not only will it constrain them, it will use it to burn off that energy. This can be in the shape of like a donut, like this, or a cylinder so that you can put your wire through it. It could also be in the shape of a toroid, which looks like this. And you can take wire and go like this and wrap it around and around and around so it goes through the hole multiple times. Basically, what happens is that the magnetic field that is generated gets caught. It gets stuck inside, and it circulates mostly around inside that material. And this is known as a ferrite choke. Now, if you have lots of magnetic fields floating around over here, and over here, after the ferrite choke, you probably won't anymore because you've burned off all the energy. It's gotten warm. Everybody here has one of these. Did you know that? And I'll show it to you right now. Everybody here has one. You probably have 50 in your house and didn't even know it. Everybody see my screen?
Yeah.
Power supply cable. What's that? That is a ferrite choke. Its goal is to take any AC that's on this power line, because this is a DC power supply, and constrain the magnetic field from the AC and burn it off as heat in that choke before it gets into your computer, because electronics don't like AC. So you can look around your house now and see that you have, on virtually every piece of electronics that has a power supply, there's a ferrite choke included. Once you get good at it, you can say, oh, well, you know what? Obviously, I have RF energy getting into my power supply. If you have, for instance, here's your computer, and here's your radio, and here's your wife's power supply for their cell phone, for charging their phone, and here's their phone. And here's your TV over here, which is, or monitor. So here's your power supply for your monitor, and here's the monitor, and here's your kid's computer. There's a power supply, and there's another computer, and these are connected together. And your transmitter is going into an antenna, which is sending out RF radiation in all directions at way more power than any of these things can withstand. All of a sudden, what you find is that your kid's computer decides that it's going to reboot. Why did that happen? This is open to everybody. Why did that happen? It just rebooted by
Interference.
itself. It rebooted by itself when you were transmitting.
Did the magnetic field from
Windows up.
Not Windows Update. Good one, though. What happened most likely is that what we have is we have RF energy that is at a particular frequency, has electric and magnetic fields. Typically, they're AC. They are going from, you have a wire going from the power supply to the computer. And what does any wire become if there are magnetic fields floating around?
Antenna.
That becomes an antenna. So if I have stuff floating around at, let's say, 3.5 megahertz, that's AC, isn't it? 3.5 megs. That is going to induce an AC current on the line going into the computer. Which, if it happens to make it into the computer, what's it going to make the computer do? And the answer is, hell if I know. Don't have a clue. Probably not good. Right? Computers run on DC power. And all of a sudden, that little line is picking up 3.5 megahertz energy, and it's sending it directly into the computer, which can cause it to behave very strangely. So what we do at that point, right here on the power line, what do we add? Everyone?
a ferrite choke?
A ferrite choke. That's right. And in fact, we can pick our ferrite chokes based on the material that it's made of. It's usually powdered metal, various different metals. So it could be nickel, it could be chromium, it could be iron, a few different things, different combinations, then powdered, mixed with glue, and baked into a shape. Depending on the metals that are used. Notice these are also the same kind of metals that are used for magnets. They'll also use cobalt. They're ferromagnetic materials. We typically bake those into a form, and these are very commonly available, and they have, depending on the mix that you use, they have different frequency ranges. So we pick the frequency that we seem to be interfering with, and we start adding chokes. If we have enough cable, we might wrap it around 2 or 3 or 4 times, and hopefully the problem goes away. And that's called RF suppression. Now, why do we have to do that? Because those devices were never designed to be exposed to that level of RF energy. So it's important to know how to remedy the problem. Okay, good grounding. Which of the following conductors is preferred for bonding at RF? That would be a flat copper strap. So we're going to bring up another topic here. See, topic after topic after topic. Okay, if I have a cylindrical conductor, so this is looking at a conductor end cross section. So here's my cylindrical conductor. If I run DC power through it, what my electrons actually disperse completely through the material, essentially evenly. So it goes up. So the power handling, etc., ampacity goes up as the square of the diameter, square of the radius. It uses the entire cross section. But when I take this same thing and I start putting frequencies into it, in other words, going back and forth, where I have current flowing back and forth in that wire instead of just always in one direction, the properties of wire, the properties of any conductor are such that the higher the frequency, the closer to the surface the electrons go. Really weird, right? In other words, you basically have no electrons flowing back and forth at the center. The higher they go, the more they go toward the outside. This is called the skin effect. what this means is that if I want to have a conductor that has a very low resistance to RF energy, because RF energy is a very high frequency, what I do is I try to take my copper, because this is copper, this is not cheap, and I try to maximize the surface area. So how do I maximize the surface area of this?
Make it
If I have
Flatten it.
pound it flat. So if I do this, I have a top and I have a bottom. Those are separate surfaces. And now I have considerably more surface area. And that's why if you're trying to do grounding, you try to give your electricity a nice, clean, easy path to follow with very low resistance. So that's why we use a flat strap instead of round wire. Okay. Let's see, if you're hooking up a radio to in a car, you would always use, if at all possible, you would always go straight to the battery. Why would you go right to the battery instead of using the cigarette lighter?
Interference.
Nope, not interference. Other reasons?
Amount of draw.
Reduce
Resistance.
loss.
That's right, because most cigarette lighters are only rated for, I don't know, 5 or 6 amps, sometimes 10. But then you've got, a connection inside, you've got mechanical connections inside the cigarette lighter. And is it wired directly to the battery? No, it goes through the fuse box. So you don't know what size fuse is in there. And so you could blow out a fuse. On top of that, what is the ground in a car? We talked about this a little bit yesterday. In a car, what is ground?
The chassis.
The chassis. Okay, so here's my car. The entire frame of the car. So the hood and the trunk and the fenders and the door panels, any piece of metal is the ground of the car, but those are all spot welded together. They're great for some things, but they're not necessarily a perfect ground. They're a pretty good path. But if you really want to, let's say that I have a radio hooked up right here underneath the front seat, and I managed to connect it to here. Well, the battery's way up here. So this basically, the negative terminal goes here to ground, and then it goes through the chassis, through all the welds, back to the battery. A better way to do this would be to go straight from, and this is a terrible drawing, I know, would be to go straight from the radio to the battery terminal. Most people who are serious about putting in a mobile radio will go straight to the battery terminal because they can use as heavy a gauge wire as they want, and they can go as short as they want. And again, a high resistance path is kind of the enemy here because it causes voltage drop, which will make your equipment not work properly.
Don't ground to the body on a Corvette.
Oh, right. It's fiberglass. Okay, let's see. So the negative terminal, the negative power goes straight to the battery ground at the chassis.
And always put a fuse in line with both the negative and positive. Is that correct?
That's a debate that I've had with a lot of people. I typically don't still, but I mean, you can, but I typically don't. But a lot of equipment comes with it. And I've never quite figured out why from an electrical viewpoint. There's pluses and minuses to doing both. I mean, you basically don't want to open your ground if you can avoid it. So, I personally just go with the hot lead if I'm building it myself.
Yeah, that's what had me ask the question. I was like, what? Why is that?
Yeah, I've noticed that a lot of power supplies, radios, they actually do that. And I don't necessarily agree, but they seem to do it. How can you determine the length of time that equipment can be powered from a battery? Okay, so looking at batteries, batteries have something called an ampere hour rating that goes all the way from your AA battery, believe it or not, that actually has a rating, all the way up to a car battery. So an ampere hour is the number of amps times a number of hours that you can draw a particular current from it. If a battery has a capacity of 100 ampere hours, that means that in theory, you could do 100 amps, but don't do it, for 1 hour. Or you could do 1 amp for 100 hours, because it's a physical capacity. It's actually a chemical storage capacity that is specified. And this is literally the amount of stuff in the battery that is providing the chemical reaction that's generating current. So that is called a battery's capacity. So if you're charging a battery, and let's say it's 100 amp hours, and you have a charger that's 2 amps, how long would you have to run it to charge the battery? 50 hours. If you have a 10 amp charger, you'd have to run it for 10 hours. Just simple math, but really important to know. Okay, operating controls. Now, this what's yes.
Can I ask a question on that? Are the amp hours usually marked on the battery, or is that something you have to figure out?
If it's a good size battery, it's always going to be marked.
Perfect.
I mean, if it's like a AA battery, it has an amp hour rating, but you can't recharge it anyway. But
yeah,
there's going to be a specification for it somewhere.
Do you do POTA, Scott?
I don't, but I do a lot of portable stuff anyway.
What size battery, out of curiosity, do you take with you?
I've got a 20 amp hour, but I've used considerably smaller. I've used like a 7. The problem is that the bigger the battery is, the more stuff there is in it, which means the heavier it is. Right. In my station, I've got a 120 amp hour gel cell. It's the size of a car battery. I don't ever expect to move it. So.
Nice. Thank you.
Yep. Okay, here we go. Operating controls. So now we're talking about microphones and speakers and over deviation and things like that. So the effect of excessive microphone gain is distorted audio. That would be basically like if I put this all the way in my mouth and started screaming at the top of my lungs, it might sound distorted, because essentially I've now exceeded the electronics ability to handle what I'm putting into it. I'm putting in a signal that's so loud that the electronics basically flat top. It's not linear anymore. So if it's not linear, then it sounds distorted. An FM receiver, if you tune it above or below a signal's frequency, you get distortion. The way that an FM receiver works is that it looks for, remember that thing we drew yesterday with the center frequency? So here's our center frequency. We expect our signal to go down and up, but we expect it to be centered. Well, if we're tuned right here, we're going to have a little bit below and we're going to have a lot above, which means we're going to have some empty space on the left and we're going to completely cut off the stuff at the top. So it'll sound all distorted and weird. You might be able to understand it, but not very well. Which of the following can be used to enter a transceiver's operating frequency? A VFO or a VFO knob or a keypad. Okay, so I'm going to bring up this. Did everybody see this?
Yes.
This is a software-defined receiver, and I'm going to make sure I'm sharing audio. Here we go, and turn the audio on. This is my VFO on the left-hand side. 707. Ooh, let's go to 21074. So I have just changed the frequency of the receiver, which is in the Netherlands, by the way, by punching in a new frequency. I can also, in this case, I can alter the VFO frequency by just sliding this. Can everybody see this okay?
Yes.
Okay. This right here is this is why this is called a web SDR, by the way. These are put out there for free. Okay, one thing I can do with this yellow bar is my passband. Notice the little vertical bar on the left-hand side? That is my center frequency. So if I were deciding whether to use upper or lower sideband, what would you say I am using right now? Upper or lower?
Upper.
Upper. If I switch it to lower, look what happens. The center frequency stays the same, but now my passband is switched to the lower side. If I went with Morse code, it's the same thing. It's always either upper or lower, unless I pick AM. Notice if I do AM, which side is it listening to?
Both.
Both of them. AM requires both. If it's FM, same thing. In this case, I'm going to go with upper sideband because I know that on 15 meters, it's upper sideband. These are digital signals. This is FT8. And if I'm lucky, I'll hear some Morse code. That looks like one. Maybe. Looks like I just missed it. By the way, this is called a waterfall display, everybody. Here we go. Okay, so that's a Morse code signal, or was. There's another one. Notice what I can do with this. What have I just done to that filter?
You squelched it down.
I narrowed the bandpass of the filter. I can also do this and make it completely disappear, and I can move my low pass portion, the low edge of it, and the high portion of it, and narrow it really, really down. So this is a filter bandwidth of 60 hertz. We would never typically do that. We would typically go to 500 hertz, like right about there. And notice I can move it around. And notice when I do that, my pitch changes because this radio is actually looking for, this is a radio. It's looking for the difference in frequency between the vertical bar, which is the center frequency, which I can slide around, and the signal of interest. So my guess is that right now this is about 500 hertz. It's about 1,000 hertz. If I wanted it at 500 hertz, I'd have to retune it. Okay, so now I'm going to take this very same filter and I'm going to move it. Here we go, 14,200. I'm going to move this to the single sideband portion of the band. Single sideband is voice. Oh, there's a band. There's somebody. Let's see if I can find another person talking right now.
That was way too fast to understand for me on CW.
Yeah, well, I've got it, but that's just me. Okay, so here's a voice. Notice how totally distorted it is? How come it's so distorted?
Too narrow.
Too narrow. We're missing
not
most of
catching
the
the whole signal.
information. So now let's widen it out. And notice that we're at about 2.4 kilohertz. So being at the right frequency, having the right filter bandwidth is very important. If we were to pick the wrong sideband, listen what happens. The speech is inverted. It's on the wrong sideband. Now we just switched it back. Okay, so let's say that we have something called squelch also. I'm going to turn on the squelch. And let's see if I can adjust the squelch. Doesn't look like I can adjust the squelch. Oh yeah, there we go. I just turned on and off the squelch. What does squelch do here? It shuts down the receiver, turns off the audio when there's nothing to hear. if I move this over here, even though it's nothing that I want to listen to, it says, oh, there's a signal there. I'm going to let it go through. So that's called squelch. And that is why this is such a wonderful teaching tool, because it allows you to show everything that you would normally actually have to have a radio in person to do. Okay, so in order to access a favorite frequency, you can just punch in a number. You can also set a memory channel. Well, most radios today have memory channels as opposed to just a knob. I've got a high frequency radio that has, I believe, 200 memory channels. I never actually get to use them for much of anything. A handheld radio like this has 1,000. I've never programmed them all. Never found enough things to listen to that I've programmed them all. FM transceivers, just like that handheld I just showed you, allows you to tune through a whole bunch of different frequencies in order. That's a scanning function. Squelch just basically wipes out the audio when there's nothing to listen to. Some people don't like listening to static. This is what it sounds like when there's nothing to listen to. There's squelch. Drives my wife crazy when I leave the receiver open. Okay, repeater offset. Okay, repeater offset. So this is something that when you program a radio, so we're now into basically setting up a handheld, setting up a mobile radio. So that means we got to bring up a repeater. A repeater is, here's the little house with your transceiver, except in this case, it's not actually a transceiver. You have two boxes. You have a receiver and a transmitter. And these are joined together by something called a controller. So what we're going to do here, for simplicity's sake, is we're actually going to put a second antenna. This is your transmit antenna. We'll make this the receive antenna. This is the transmit antenna. Notice that they are separate. So what a repeater does is there's a signal that comes down. I'm going to draw this in blue to the receiver. If all the requirements are met, so that means there's a signal there. If there's something called a CTCSS or a DCS squelch, this is continuous tone coded squelch system or digital coded squelch, the controller will basically take this audio and listen to it coming out of the receiver and decide, okay or no good. Is this something that is a valid signal? If it's a valid signal, what it will do is pass it on to the transmitter, which then comes this way and then out the transmitter. So if these were operating on the same frequency, what would happen? The transmitted
Overlap.
signal would get into the receiver and you'd have a feedback loop and the whole thing would lock up. So what we do is we have something called an offset. This is a frequency difference between the receive and transmit. On the 2-meter band, which is 144 to 148 megahertz, this is something that you're going to become very familiar with. The offset is 0.6 megahertz. And it's either up or down, which means that we are going to transmit our signal to the receiver at a different frequency than we are receiving. So we are going to have to be opposite what the repeater is doing. Our radio is going to have to be transmitting on this frequency and receiving on this frequency. And again, this difference is 600 kilohertz on the 2-meter band. So the repeater transmit frequency is the specified frequency of the system. So if this is, let's say, 146.72 megahertz, and they specify a negative 600 kilohertz offset, what would the receive frequency be where we would have to transmit in order to access that repeater? It would have to be 600 kilohertz or 0.6 megahertz lower. So we would have to switch to 146.12 megahertz to send a signal to the repeater. The repeater can also specify that this has a CTCSS or a DCS. That could be, this is that a CTCSS is a very low frequency tone between 67 to 253 hertz. So they call it a subaudible tone. It's very low amplitude and it's very low frequency. So if the repeater specifies a tone of 100 hertz, that means that you have to turn on your CTCSS at 100 hertz when you transmit. That is the key, that when the signal gets down to the controller, which is basically a computer with a couple of radio frequencies with a couple of switches, when it gets down to that point, the controller will consider it a valid signal. So this is a basic repeater system. So now one thing I'm going to bring up is the fact that once we have this, so let's say that we have no room to put up two antennas. We have one antenna. And this is connected to our receiver, and this is connected to our transmitter. Well, okay, how do we do that? Doesn't that seem kind of weird that they would be on the same, even if it's receiving on 146.12 and transmitting on 146.72? We have to have some way of isolating those signals. I mean, even if we're transmitting a pure tone, a pure frequency doesn't exist. You know, there's a little bit of noise on either side of it, and those are gonna kill each other. We obviously have to do something special here.
Polarity.
Nope. We have to do something even more special. We have to somehow separate 146.12 from 146.72. And we have to make sure that 146.12 has a path that goes that way, and 146.72 only goes that way. How do we separate two frequencies from each other?
For you use a transistor?
Nope. We kind of talked about it a little bit yesterday. Yeah. Okay. What's an isolator? How do you build it? What are the two things that make up? If we were to draw our frequency chart, so here's our frequency, 0 to infinity, we have one signal here and one signal right here. And for the sake of argument, we're going to make it wider. We're going to spread this out. So we have one signal there and we have one signal here. How do we selectively go after one of them while ignoring the other one? Come on, we do it all the time.
Use a bandpass filter.
Yep, we have a filter. We use a bank of filters. And one of them is tuned very, very, very tightly to only allow that frequency through. And the other one is tuned very, very tightly to only allow that frequency through. So these filters are not your normal filters that just look like inductors and capacitors. Because these frequencies that we're using are very, very close together. And does anybody want to use, does anyone want to build a transmitter that runs like 1 milliwatt? Does anybody want to use one of those for a repeater? It's not a very good repeater. Most repeater transmitters are 50 watts. Well, okay, so now we start looking at our math here. Okay, so 50 watts. Erase that. I don't like that. Okay, so 50 watts. our receiver is sensitive down to about 1 microwatt. Or, let's even go 0.01 microwatts, which is very, 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 very little. And so even if we are transmitting on different frequencies, we need to make sure that there is no energy from here that causes that much signal. So now we start talking about isolation. So what we're going to do is we're going to figure out, going through decibels, how to get from 50 watts down to 0.01 microwatts. So we're going to just start dividing, and let's make it 100 watts for the sake of argument, just to make the math a little bit easier. Okay. And let's see, who was I working with who's an expert on decibels now?
Eileen.
Eileen. Okay, Eileen. Okay, we're going to start dividing by 10. We're going to start at 100. What's our next step?
Okay.
We're going down. Just using
Okay,
factors of
so
10.
you have 10 decibels.
Well, yep, we're just going to go down to 10. We're just going to draw the steps. Then you go down to 1. What's next? 0.1. Come on, Eileen. Just keep dividing by 10.
Okay, it's 0.01.
Keep going.
And then 0.001.
Okay, and then
Point
zero
zero
zero one.
zero zero one.
All right, and for the sake of argument, I'm just going to keep going. 0.001, and I need 0.1 microwatts. So that would be eventually 0.0000001. So let's count those steps. 1, 2, 3, 4, 5, 6, 7. And let's see, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, and 2 more steps. And every time I change by a factor of 10, how many decibels is it?
10.
Okay, so that's 10, 10, 10, 10, 10, 10, 10, 10, and 10. Add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. I need at least 90 decibels of isolation between those two filters to keep the transmitter from wiping out the receiver. I mean, this is a perfect practical application of filtering and understanding what decibels do for you. And remember I talked about the Baofeng question? Remember 2 days ago when I said Baofengs are crap? Baofengs, essentially, when they're listening to a particular frequency, you ideally want a lot of isolation right outside of the frequency that you're listening to, so that there's not all this excess energy, which is there floating around in the atmosphere, coming into your radio, forcing your radio to try to amplify it. You do not have, if the front end filtering is no good, you don't have that isolation, and your radio becomes desensitized and doesn't work. See, I told you we'd get to exactly why I don't like them. I told you that, and here we are. So when you're building a repeater, what you end up with is some very, very, very tightly calibrated and very high isolation filters. Anybody want to see what that looks like? I can show you a picture.
Okay.
Okay, here we go. Here comes a picture of it. Here we go. Let me share this. There you go.
Whoa.
That is a repeater duplexer. Notice each one of these is a big metal, it's a big aluminum box and it has an input and an output, and the thing on top is a plunger that allows you to very accurately set the frequency. And notice power rating 400 watts, works fine. Notice what the isolation is. How many decibels?
85.
85 dB.
And
So-
50 ohm impedance.
And 50 ohm impedance. So basically you have an input and an output, and you typically have band pass and band reject and low pass and high pass filters. And the overall thing, notice what the price is.
Mhm.
This is why you join a radio club,
Yeah.
because most people can't afford that themselves. But a club can afford it, you know? So now we're going to get to the concept of filtering. So if I want, let's say a frequency here, and I build a filter that goes from 0 up to that frequency, this is called a low pass. If I want a filter that goes like this is called a high pass. If I manage to put those two together and I have a filter that looks like this, that is a band of frequencies. That is called a bandpass filter. If I can manage to build a filter that looks like this, let's say that there's an FM radio station 15 let's say 150 feet from my house, and it's getting there's noise coming in, it's wiping out my radio. That would be called a notch filter, because it looks like there's a notch taken out of the bandpass, of the passband. The fundamental things that we use to do all of these are these and these. And remember that capacitors allow AC to pass, and inductors allow DC to pass at various degrees. If you put them in series and in parallel, you build a tuned circuit. You build a tuned circuit, you can select all of these things and make all these pretty pictures and let only the things through that you want. I told you I was going to teach you a lot of stuff during this class. Okay. What function is performed using a digital mode hotspot and a transceiver, communicating using digital voice or data systems over the internet? A talk group. Okay, this is DMR. A talk group is the concept of splitting a frequency in time. So if you wanted to split, let's say you had 2-second periods, for 1 second, group A gets it. For the other second, group B gets it. And during that opposite time, neither group listens to the other group. And because they're digital, you just basically get a data stream that is only meant for one group, and everyone else's radio, because they know where they're listening to, they don't listen to the wrong one. That's called a talk group. You program your radio with the group's ID or code, and you only end up using the one that you want, which basically means you can have 2 simultaneous conversations on the same frequency and they don't interfere with each other, which doubles the amount of information that can pass. DMR code plug is how your radio is set up to talk over DMR, which again is digital mobile radio. It's a handheld radio that is digital instead of analog. Analog is how we're talking right now. Although once my voice goes into my computer, it's actually being converted into digital signals, which are then being sent as ones and zeros over the internet to you. So my voice is analog, and we're actually using something very similar to digital radio. Fortunately, there's a digital to analog converter in each of our headphones, so we don't actually just hear ones and zeros. A specific group of stations is selected on a digital voice transceiver by entering the group's ID code. The interesting thing about DMR, there's something called a color code. The really interesting thing about DMR is that there are actually multiple. This is the Betamax versus VHS fight. There's something called Fusion, which is a Yaesu thing. There's something called DMR, which is kind of an open standard. Then there's something called D-Star, which is an ICOM standard. ICOM and Kenwood, actually. So there are actually 3 competing versions of digital mobile radio that all exist and are used today. Again, you know, just like beta and VHS, and they are not compatible with each other, of course. But the interesting thing is that you can have a digital mode radio that is talking to another one. And let's say that you're on a local repeater and you have group 1 and group 2, and these are big groups and they can be anywhere, and the repeater is selecting them like this and retransmitting signals. But now you also have the repeater connected to the internet, and if the internet is in good shape, this goes into the internet, and somewhere out there, there's a person who is on a cell phone or has a hotspot. It could be either one. Here's a cell phone. Here's a hotspot, which is a gateway to go from digital to radio. So here's their local radio. Here's another repeater. Because these are all digital signals, you could have people here on group 1 and group 2 who are actually talking to the other group 1 and group 2 people, even though they might be a few thousand miles away, just using a handheld radio with the internet as the bridge. So some very, very cool stuff that is done these days. And there's a lot of development that's taking place. There's a lot of opportunity for people to get in on the ground floor of a lot of this really cool stuff. As we heard on single sideband, we typically would set a receiver for 2400 hertz. As we noticed, if we tune to the wrong sideband, it doesn't sound right. If we tune off frequency, it also doesn't sound right. There's something called a receiver incremental tuning, or a clarifier, which allows you to sort of tune in the sound of somebody's voice. It operates separately from the transmitter so that you can basically just make sure that somebody sounds right. And if they did the same for you, then you didn't move your frequency and they didn't move theirs. So otherwise you'll end up chasing each other up and down the band.
Is that the VFO knob on older radios too? Or?
No, the VFO will actually change your transmit frequency also. So the reason I say that is because the receive and transmit frequencies are tied together. So let's say that you're on the band and here's station A and here's station B. They are supposed to be on the same frequency, but they're not. So you're on upper sideband. So your signal is, let's say, here. Well, the other person says, oh, well, that's not where they're supposed to be. So they tune their radio to this frequency. But then when they transmit, their signal moves because they were transmitting here. Now they're transmitting here, but your radio is already on the wrong frequency. So in order to hear that signal, you move down here. But now you're transmitting of the wrong frequency. So what the clarifier or receiver incremental tuning allows you to do is literally increment the receiver frequency only and move it slightly without altering the transmit frequency. And then you don't end up chasing each other up and down the band, which used to happen before there was such a thing as an RIT. A transceiver's PTT input, which is push to talk, switches the transceiver from receive to transmit. And let me see. John, are you here this morning? Is John here yet? Nope, John's not here yet. Okay. All right. Station equipment, receivers, transmitters, transceivers, and transverters. A transceiver is a receiver transmitter combo, all in one box. A transverter is a converting receiver and transmitter. So why would you want to do that? Well, let's say that I have a transceiver right here, which is a ubiquitous transceiver that operates on 28 megahertz. But I really want to operate on 222 megahertz a band for which there is precious little equipment. This is a device called a mixer. And what a mixer does is it takes one frequency and adds another frequency from another port. And in this case, it would be at 194 megahertz. And it does sum and difference. So it adds and subtracts them. Well, the addition would give us 222. The subtraction would give us 166. Well, which one do we want? We want 222. What would we do to do that? How would we get that frequency and not the other one? What do we build, everybody? Come on, what do we build?
Filter.
Filters, right. And then again, we are back to the ubiquitous and very important capacitors and inductors, because those are the basis for filtering. So this is a mixer, which is at the heart of a transverter. So here's a filter. And from there, we can go up to our transmitter. Now, the
Not to
interesting thing about,
sidetrack you.
or to our antenna. The interesting thing about this is that we can actually build it so that it works both ways. If we have 222 coming in, we'll get 28 coming out, but we'll also get, let's see, that would be 416. How would we make sure that that doesn't get back into our radio?
Filter.
Everyone, another filter. That's right. Filters, filters, filters. Okay, and that's at the heart of something called a transverter. Okay, what device increases the power output from a transceiver? An amplifier, an RF power amplifier in particular. An amplifier can be a vacuum tube. It can be a transistor. Those are amplifying devices. It's important to remember that an amplifier does not make something bigger. It makes a copy of something in a bigger form, which is why it's important if we're trying to make something like my voice, which has lots of different frequencies and tones and amplitudes. We want something that's linear. That's why a linear amplifier is essential. Okay, the SSB CW FM switch on a VHF power amplifier, single sideband is like analog. It's me talking, it's my voice. That causes, if we use that single sideband switch, it causes a power amplifier to operate in a less efficient but more linear mode than if it were in CW or FM. CW is just Morse code, on or off. It doesn't really matter if it changes pitch because there's no pitches to change. And the same with FM. FM just sends a whole range of frequencies which get clipped when they get to the receiver anyway. So that's why you set the amplifier for the proper operation. If you're using FM, the FM setting is going to be more efficient and save some power. The ability of a receiver to detect the presence of a signal is its sensitivity. The ability of a receiver to discriminate between multiple signals. This is like when you walk into a crowded room and you're having a conversation with one person. It's called selective hearing. According to my wife, I have it very badly. But usually when it comes to, chores that I'm supposed to do.
This is why we don't use a spark gap anymore.
That's exactly right, because it blasts everybody everywhere. A receiver preamplifier typically is going to go in front of the receiver. It amplifies signals that are coming down from the antenna. Because cable that is near the cable that is going between the antenna and the radio has loss, you will actually lose signal between the antenna and your equipment. If you're listening to a very, very weak signal and it has to come down the antenna just to get to the preamplifier, it might already be gone by the time it gets there. So let's say I have an antenna and I'm listening to something that is minus 125 dBm. That is the strength of the signal. The M stands for a milliwatt. That is the strength of the signal that exists. Let's say I'm listening to somebody bouncing a signal off the moon. That signal is coming down through the cable, which has a loss of 10 dB. What is the signal going to be by the time it gets down here? minus 135 dBm. If my receiver has a sensitivity of minus 130 dBm, guess what I hear?
Nothing.
Nothing. That's right. The signal is non-existent. If I put a preamplifier which boosts it, and I put the preamplifier right here, will that help? No, because there's nothing to be amplified. The signal is already gone. In some cases, then what I do is, if I'm running a moonbound station, is I will put a 10 dB preamp up here at the antenna. I'll boost my signal to minus 115. By the time I get down here, now it's only minus 125. And guess what? I am happy. My station now works. This is why it's important to understand how signals pass through a system and when they get stronger and weaker and where signal gets lost and built back up. This is why cable TV systems have repeaters along the way, because you can't amplify and make louder what you can't hear. A device that converts a signal from one frequency to another is called a mixer. We just talked about that. A device that generates a signal at a specific frequency is called an oscillator. And the concept of putting information onto a signal is known as modulation. That could be either turning it on or off, making it bigger or smaller, changing the frequency, changing the phase. Everybody ready for a 10-minute break?
Yes.
Okay,
Sure.
excellent. And I'm going to see if John is here. John was going to be here to answer any questions you might have about digital stuff.
Oh yeah, there's two Johns in the chat, John and John Henry Weber.
Oh, let me see it. Well, this is Riverfish John. Let me see if he's. I'm going to send him a note. So, all right, 10-minute break, y'all.
Cool. It's pretty good. Let's be on a break. So anyway, I'm still home.
Okay, so while I'm sitting here, if anyone has any questions, we can talk about that too.
Scott, this is Phil.
Yeah,
I have a question.
okay.
It's about antennas. I live in a rental duplex and I can't put anything on the roof. The landlord's got a metal roof up there, and I want to put up a dipole kind of away from the house. And I was wondering, what's the difference in efficiency between a horizontal dipole compared to an inverted V dipole?
Similar.
Oh, okay,
Yeah,
good.
it's similar.
Thank you.
You're gonna end up with if it's an inverted V, you're gonna have a little different radiation angle.
Mm-hmm.
I mean, because you basically have a donut sort of around each. So you're going to have, it's going to be off, you know, basically perpendicular to the antenna, but then you're going to have the lobes that were normally pointed upward are going to be tilted downward slightly. So it, in some ways, it's actually a better antenna if you can get the center point up nice and high.
Okay. So the each different beam compared to the feed line, is that about a 45-degree angle?
You know, it depends how much space you've got. Really.
Okay. All right. Well,
I mean,
I'll
one
have,
thing is you don't want the ends on the ground,
right.
because those are the high voltage points, and then you're going to end up with leakage, which is basically loss of power.
Okay.
It'll
I think
induce,
I'm good.
you know, it becomes a capacitor, it'll induce currents in the ground, and that tends to waste energy.
Very good. I should have fun with that.
Oh yeah, antennas are the best because, well, because it's, you know, it's physics meets the real world, and what's in the book and looks like it should work. Oh my God, it doesn't work at all. But sometimes it does. It gives you a good starting point. So antennas are the best. They're still, you know, in a lot of ways, it's the Wild West, you know. You just grab yourself a bunch of rope and a bunch of wire and a tennis ball cannon or something,
Mm-hmm.
and shoot it up in the trees, or
That's
put
what
it
I'm
up on a
planning.
put it up on a fiberglass pole and see what you get.
Okay.
That
Well,
and
thank you very much.
that's why, I mean, a lot of us, like, I've never spent more than $20 on any antenna. Well, I
That's
take it
my
back because
budget.
I've had to buy wire. Okay. So I'll have to up that. The wire is actually not that expensive. The feed line is a little more. Okay, I'll say I've never spent more than $50 on an antenna.
That fits my budget.
I'll go with $50.
Okay.
And a lot of times, like, you know, because I work in an electrical shop, if somebody is getting rid of, like, you know, some bizarro color of wire that they bought for a project of 18 gauge wire, so yeah, we're never going to use this. Like, I'll take it. So I end up with, like, you know, 250 feet of some insane colored wire that we never use.
Mm-hmm.
I can use it. I don't care what color the insulation is. It's all going to be gray in a few years anyway.
True.
Seen a lot of chat on Facebook groups for ham radio about recycling busted Christmas light wire for antennas as well.
I don't see why not.
Hey Scott, I got another question.
Mhm.
If could you direct me to some resources for project ideas for like antenna building for beginners?
Oh, I mean, there's, if you
I don't know if you have any that you particularly like or have any off the top here. I guess that's mostly. I mean, I've seen a lot online, but
there's a
I'm just
lot.
curious if
I
you have.
mean, there's, I mean, there are like entire volumes. There's something called the ARRL antenna book that is just nothing but antennas, and it's 2 inches thick. You know, then you have like the antenna compendium, and then there's another book that's antennas for low band DXing, and there's, you know, the dipole antenna book. It's nothing but dipoles and variants of dipoles. I mean, there's And the other cool thing is that there's nothing saying that if you can sort of visualize how electrons move around and phasing. We haven't done phasing. We haven't done, I mean, we understand phase, but we haven't done phasing. We haven't done arrays and stuff like that. But let's say that I have an antenna here and an antenna here, and these are separated by, oh, let's say a half wavelength. And these are fed signals with equal length cable so that the waves arrive at the same time. So I will have something that goes like this. They're in phase with each other. When they get to here, they're going to be in phase with each other and they're going to add. But if they're also traveling this way, 1, 2, the half wave apart, so they're going to be separated by that. Then this is going to be sending out a signal and going like that. What happens in this direction?
It's destructive.
Destructive. You're going to have a more directional array. You can actually put more of these together. You can do all kinds of cool stuff like, okay, well, I can take 3 things and I can phase them a certain distance, but then in order to do that, I have to have this cable of a certain length, and I want this cable longer and this cable really short, so that these actually receive the energy at a slightly different time. So by spacing them by a certain distance and by changing the cable lengths a certain amount, I can change when each of them transmits, and I can make an array that transmits what's known as end fire, or I can make the array transmit broadside. And oh, well, if I have that already set up, what if I have switchable delay lines in my cables, right? I can do this on one of the cables. So this one's extra long. I can change it. But then I also have a switch between this point and this point, and I can get rid of the squiggle and switch it to a straight line. I can change when the waves get there. I can change what the pattern looks like. Antennas are really cool for that reason. Antennas. So here's, people want to go and they want to buy an amplifier and they want to do all kinds of things. They want to spend a lot of money. Oh, my signal's not big enough. I need an amplifier. So what does an amplifier do, everybody? What does a power amplifier do?
Increases the gain of a
Nope.
signal.
Yes,
the
it
signal
increases
that's
the
already
power.
there.
It increases the power of a transmitted signal, right? What does it do for your receiver?
Oh, nothing on that end.
Nothing.
Nothing.
That's right. So you want to you want a better functioning system. What do you do with how do you increase your gain on receive and transmit simultaneously? There's only one device that does that.
Better antenna.
Better antenna. And that's not necessarily the biggest cost, is it? I mean, it could be, but it's not necessarily going to be the biggest cost. An amplifier might set you back $4,000. For $4,000, if you have the room, you can put up a modestly sized tower and a big antenna, and it works better on both sides. So, like people say, oh, I got to get a linear. No, you don't need a linear. What you need is a decent antenna. The rule of thumb is you can take a meager radio and hook it up to a big antenna and have a killer station. You can take a great radio and hook it up to a crappy antenna and it doesn't work at all. You could spend you can get an Elecraft K4, which is a $5,000 beautiful radio, and hook it up to a crappy antenna and it doesn't work at all. Antennas, the antenna is your window that you're looking through. You know, if you
I-
give it a little tiny window, you don't see very much.
Putting cheap tires on your Ferrari.
Yeah. Or let's say you build a telescope, right? And you build a small telescope out of crappy parts and you expect it to be able to see really far into the universe. I mean, basically an antenna is essentially a radio version of a telescope lens. The bigger the antenna, the better the antenna, the better it's going to see. All right, everybody ready to keep going? Got more questions before we go?
Yep.
One more question.
Questions are great.
I'm having a hard time. I have 4 years of electronics in high school 50 years ago, but they've had a few innovations in electronics in that time.
A few.
And so there's a great many more acronyms that I'm having a hell of a time with.
Okay.
You have a list of acronyms, explanations of all these things?
Like what in particular?
CTSSCC.
A what? Do that again.
The
CT
CTCSS.
CTCSS, it actually existed 50 years ago.
Okay.
CTCSS.
EMR, D-Star.
Yep. CTCSS is continuous tone carrier squelch system. This is also known as PL. If you're familiar with the Motorola world, they called it private line.
PL tones.
PL tones. Yeah, that's exactly what that is. Those are PL tones. And that's Motorola's trademark, PL. Then there's DCS, which is digital carrier squelch. This is basically a very, very small amount of frequency hopping of your signal that your radio is supposed to follow. And if it's not following the right sequence, then the receiver doesn't retransmit it. And that's digital carrier squelch. And it's digital because the amount that it jumps is a digital, I guess, because it's a digital thing. And it follows a sequence. Continuous tone carrier squelch system is obviously continuous tone. So it's transmitted continuously. DMR, digital mobile radio, D-Star, yeah, that's just something that ICOM came up with. Fusion, that's something that Yaesu came up with. These are all just digital radio. And that's just essentially converting an analog voice into a digital bit stream and transmitting the digital bit stream.
I was just wondering if there's some kind of a sheet that I could look at to memorize.
If you come across something that you don't know, you just look it up. That's what I do.
Well, and in the study guide that you gave us, there is
Yeah.
at the very back, there's a list of the
Oh, is there?
terms and some definitions. Yes.
Ooh, okay.
I don't know if it's all the acronyms, but I know there's
Now I
quite
gotta
a
go
few.
Thank you.
Happy
No,
to help. I feel like I'm back
100%.
in high school and college cramming again.
Oh, look, there's DMR. Wow. You know, I did not know. I never looked back there.
Was that in the no nonsense tech
Yeah.
study guide?
Yeah, that's in the last couple pages
Yep.
of the guide. Yeah, look at that.
Oh, okay. Okay. Thank you.
Okay, so let's see. We are past station equipment. And we are on to system causes and cures of common transmitter and receiver problems. Okay, what we will see here is that most things lead to distortion. Distortion is basically if you're trying to amplify something too much, something's too loud, you're out of the linear range of a transmitter, linear range of an amplifier to do its job. That's going to be distortion. Okay, things that can cause radio frequency interference. Fundamental overload, that means there's a big signal nearby that's desensitizing your receiver. A harmonic, so if I'm transmitting at 10 megahertz, a harmonic is an integer multiple. of that frequency. So the first harmonic of 10 megahertz would be 20 megahertz. The second harmonic would be 30, then 40, then 50. And a spurious emission is a non-harmonically related transmission frequency. So my 10 megahertz transmitter is putting out a signal at 17 because something in there is doing something it shouldn't. Now, interestingly, in order to remember, we were talking yesterday about people who will occasionally use a radio on a frequency that it was not intended for. Okay, when you look at something called type acceptance, part 97 is the amateur service. Part 95 is like citizens band and family radio service and things like that. Part 90 is commercial radio. Okay, part 97 is the rules and regulations for ham stuff, right? There are essentially rules and regulations for ham stuff as far as here's our fundamental frequency, and it's something like this, and this is measured in, like, we'll call this 0 dB. All harmonics and spurious emissions must be at least, depending on the band you're on, 40 or 50 or 60 dB below the fundamental. So what this means is if somebody sells something as a ham radio, it has to meet these specifications. But at the same time, you can go over to this radio, like this handheld radio. I can punch in a frequency. It's frequency agile. I'm allowed to do that. I am also, if I really want to, allowed to build my own version of this because the assumption is that I have been through the examination process and I know these rules that say part 97 says that all equipment must be either 40, 50, or 60 dB down, depending on the frequency that you're using. I am assumed because I have a license, I have an amateur license, yes, even a technician class license, which is the entry-level license, that I understand what these rules are as far as suppression of unwanted frequencies. I'm allowed to build my own stuff. If I build my own stuff, it is assumed that I understand what this means, what suppression means, and what decibels mean. If I instead go and buy a part 95 radio, in the book, there will be something that says this is a part 95 radio. This is written into the Code of Federal Regulations. It's actually in the United States laws. It's written in the FCC rules that says that for this particular thing, I can go to channel 1 or channel 2 or channel up to 22. And each of these specifies a specific frequency, 462.075, 462.100, et cetera, et cetera. And I am not allowed to change those. I am not allowed to go in and take this radio, which should be at 462.075, and tune it at 462.080. I am not allowed to do that. This is a packaged piece of equipment that has to meet the specific rules. I can't go, unlike a ham radio, and just change the frequency willy-nilly. I can also take my ham radio, for instance, and hook it up to an amplifier where I might be able to run 1 watt. I hook it up to an amp, I run 10 watts. I hook it up to a bigger amp, I run 100 watts. A bigger amplifier, I run 1,000 watts and hook it up to any antenna. In the rules, a part 95 radio might say it has to be a permanently connected antenna with a maximum power level of 0.44 watts. Right? So when somebody sells something that is part 95, it has to meet those rules. This is designed for consumers. Part 90 is business band radio. And even though the power levels are different, there are basically specifications. It is assumed that the person that's using it is a user, not a technical person. This is basically an appliance. And the assumption is that there's going to be nothing they can do to not make it work like an appliance anymore. It can't be tuned to a different frequency that is not planned. It can't be set to a different power level. Maybe the rules allow it to be hooked to a bigger antenna, but it still has to follow, the rules. You're not allowed to build something yourself that meets Part 90. It might meet Part 90, but you can't get it certified as that. So does everybody see now the problem with, let's say, taking a Baofeng, which is a Part 97 radio, which can be tuned from 136 to 174 megahertz, and using this and also from 400 to 512 megahertz. There are a lot of different frequency ranges here. There are a lot of different services that are Part 95, such as GMRS. There are a bunch of Part 90 services, such as, we'll say, MERS, which is a multi-use radio service. There's also lots of different mobile radio stuff and things like that. This radio can be tuned to any of those services. What's the problem in doing so?
You don't have a license to broadcast.
Well, even if you do, let's
It's not
say
part specific, it's not according to.
there is no guarantee that it meets the regulations that specify what a legal radio is there. The deviation of the signal, the width of the FM signal that's put out might not be exactly what you want it to. It certainly isn't necessarily going to observe power levels. You can dial in a new frequency, which you're definitely not allowed to do. And that's why you can't take a Baofeng radio, for instance, and legally use it to transmit. Even though you could transmit with it, you're not legally allowed to, because it doesn't meet those specifications.
Out of curiosity, I got a UV5R and tuned it to some GMRS channels that are used at my work. And just I did test, it did not transmit at all. Nobody could hear.
Yeah. Well, it might be that it is in the software, it's blocked. But if you have chirp, it is very easy to unblock. So
are there radios that are actually set up to do both Part 97 and 95?
There are some, but they are typically more expensive, and they have to be purchased as, like, I could take any Part 90 radio, and if I could crack the software and make it so that I can program it and move it to another frequency, I can use any of those radios and use it as a Part 97 radio. I can take a CB and modify it and use it on 10 meters, so long as I know that it meets the specifications of Part 97. I could take a commercial band handheld. I've owned them. In fact, most repeaters are actually Motorola and Kenwood commercial radios, because there are a lot of them out there. They're really, really rugged, and they last forever. But those are actually designed as Part 90 radios. There's something called a Motorola Motrack. Anyone ever seen a Motrack? It's about this big, 1.5 feet long, and weighs a ton. Completely bulletproof.
Because
Okay.
there's for off-roading, you have a lot of clubs will use GRMS and have ham radios, and that's why I was just wondering, instead of carrying two of them.
Well, legally, you're not allowed to do that. You could get, if you can find a radio that is legally type accepted for GMRS, then you can do it. The question is, are you going to get in trouble? I'm going to go la 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 la. But if you have a license and you know better, then you probably should know better. You're basically risking, let's just say that the fines for illegal transmissions are not small if the FCC wants to make an example out of you.
It's just bad form,
Yeah.
besides everything else.
Yeah, exactly.
And for goodness sakes, the cost of the fine drastically outweighs the cost of buying the separate radios.
That's exactly right. Okay, and I know Kent's back. Let me just let me just get through this one thing here. Radio frequency interference, we talked about that. Okay, part 15. A part 15 device is an unlicensed transmitting thing. So my power supply is a part 15 device. My computer is a part 15 device. In addition, any part 15 device has to accept all interference from any other licensed service. So if I were to transmit and my neighbor's computer decided that it was going to reboot, that is not really my fault. I would, of course, go through and make sure I'm not doing anything I'm not supposed to be doing. I don't have a lot of stray RF floating around. Beyond that, you know, I'm not legally required to help my neighbor. Now, if I like my neighbors asked me very nicely, you know, maybe I'll go and we'll put some ferrite chokes on there so their computer doesn't reboot. If it's my wife's computer, I probably want to make sure that it doesn't suddenly reboot because, you know, that's a little closer to home. Non-fiber optic cable TV interference. Connectors tend to loosen up for whatever reason. Those little F connectors on the back of your cable box, they just loosen up. If they loosen up, they leak. And it turns out that cable TV runs a giant range of frequencies from very low to very high. So you get a little bit of leakage in and you lose a signal. Broadcast AM or FM radio. In other words, like your car radio, somebody pulls up alongside you and transmits on their 2-meter radio and you hear them. And that's because it's outside of the band, but the signal is so strong that it can't, that your car radio can't do anything about it. I used to actually have an AM radio station. It was WJOK, all comedy all the time, 15,000 watts, 2 miles from my house. When I drove by the station, it didn't matter what my radio was tuned to. I could hear it. How can you avoid this? You can put a filter at the antenna input. If you have an FM radio station nearby, you could actually have an FM band reject filter, which is specifically tuned for the FM radio band. Something in your neighbor's home is causing interference to your station. This actually happened to me. I had a neighbor who was about 3/4 of a mile away, who had a whole house, I think it was called like a jackrabbit for their phone system. It allowed them to basically use their house wiring to extend their telephones. Well, what it did, it was on 3.523 megahertz, which is right smack in the middle of my 80-meter CW band. And I could hear them, and I could actually demodulate them on FM, and they were super, super loud. I was able to figure out who it was and say, hey, you know, you're broadcasting your telephone calls all over the neighborhood, right? He said, I'm what? That was a part 15 device. Not only did we figure out what it was, but they said, I never want to see this again. Please make it go away. A problem if you, what might be the problem if you report that your audio through an FM repeater is distorted? Well, if you're off frequency, if your batteries are low, that means you're not deviating properly. Your frequency maybe is unstable. You could also be in a bad spot physically, in which case your signal is maybe using multipath, or multipath doesn't sound very good either. RF feedback, guess what? It sounds distorted. If you have basically RF energy getting back into your microphone, sounds bad. If you're using a handheld radio, you don't have a microphone gain. This is your microphone gain. If you're too loud, you move it away. If people can't hear you, you make sure you talk closer. And okay, test instruments and soldering, we're going to get to after Kent.
Oh, by the way, on thanks.
What you got, Kent? Kent,
No audio.
we can't hear you, Kent. Oh, Zoom is great sometimes. Still can't hear you. Yell louder.
How about now? 1, 2, 3.
Yeah, there we go.
Okay. Sorry about that. Hey, on that on the microphone gain issue, by the way, the newer handhelds, or some of them anyway, like my Anytone 878, it actually does have microphone gain as a gain setting. Yeah, it does. Anyway, hey, I just want to let you know, we're going to try to start testing early tomorrow. I'll be sending an email out to everybody who's registered to let them know. So if they're available, great. If they're not, that's fine as well. But we are going to try to start testing about a half hour to an hour early tomorrow. So you might start getting phone calls. Okay. But I will send an email out to all registrants this afternoon. Okay.
Am I going to be operating the phones?
You are going to be yes, you're going to be phone man.
I'm going to be phone man. All right. It's funny because I hardly ever operate phone.
Hey, Ken, I have a question.
Come on, that was a joke.
Go ahead.
So I'm actually planning to go down to my office because we're closed for the week. And I figured that'd be a good quiet place to take the test. So when I get a phone call saying, hey, how soon will you be ready for testing, or you're next up, how much lead notice am I going to get? 10 minutes, 30 minutes?
Do you want to go early or late? Do you want to schedule it?
Hey, that's an option. I'd love to.
We could make you first, in which case, when the time comes, you're up.
So I'm going to send an email out to all the candidates today. If you have some special request, I'll put it in the email. I'll ask that you please respond to me and let me know what it is. Okay.
Thank you.
You bet. Anything else? I keep interrupting you, Scott. I'm sorry.
No, that's cool.
Okay. Okay. If that's the case, I'll get out of your hair here. I just wanted to give you guys a little bit of a heads up. Okay.
Indeed.
Enjoy your class. And
Thanks.
man, Ferrite is listen. Ferrite is a beautiful thing. It's a great investment if you got RF problems. Put it on everything.
Yep. And
all right,
you know what, Kent? On my USB cable between my PC and my radio, I have 5 ferrites.
I believe you.
But you know why I have 5 ferrites on it? Anyone? Come on, somebody's got to know this. Why do I have 5?
Many adapters?
Your wife keeps buying.
No, because 4 wasn't enough.
Yeah.
I still had problems with 4.
And
so
the
5.
We use the big ones too. I mean, if you've got RF issues in your shack or RF getting into things around your house, ferrite, toroidal core, ferrite beads, cores, whatever, that stuff could really help you out. So it's good stuff.
Can everybody see this?
Yep.
Ferrite, the world's largest maker of ferrites. So suppression components, power components.
There's about 3 manufacturers of this stuff.
Yeah.
And good material. We bought big box. We have like 3 boxes of these things.
Yeah. I have like a whole bunch of different sizes. I have different mixes for different frequencies. Everything. I mean, I actually got a whole bunch of the clip-on ones. I was at some ham fest and somebody had a jar of them. And I bought the whole jar because, they're usable for everything.
But if you can wrapping is really good.
Because that's multiplicative.
Really good.
You get a multiplicative effect if you wrap it multiple times.
All right, I'll leave you alone. Thanks a lot. Goodbye. Have a good day.
Kent.
And good luck tomorrow.
Study hard, everyone. Thanks, Kent.
Bye.
Okay, so now getting back to this. Any questions before we go on? Nope. Okay. Test instruments and soldering. Okay. So if you're going to be building your own stuff, you're going to be using test instruments and soldering. If stuff breaks, you want to measure a voltage on a battery, you're going to be using test instruments. So here we go. We're going to draw a basic circuit again. Here's our basic circuit. Okay. So we have a voltage here. We actually have a voltage drop here. If we want to measure our voltage, we use a voltmeter right here in parallel with the battery. If we want to measure our voltage drop across the resistor, we actually use a voltmeter across the resistor. This basically allows us to measure what our difference is between 2 points. If we want to measure our resistance, well, we'll get to the resistance in a minute. If we want to measure the current, we actually break the line and we put an ammeter, which is a current meter, in series with the circuit, because everything that flows through the wires has to flow through the meter. Now, there is another way to do this. What does every wire that's carrying current produce? Everyone, what kind of field?
Magnetic field.
If we were to take a coil and do this with it, and we would hook that up to a voltmeter and an ammeter, what would we get? We would get current making a magnetic field, and the magnetic field making a current, which we can then measure. Well, guess what? If we can measure it, we can figure out how big the current was that made it in the first place. This is a special kind of ammeter called an inductive, notice that word inductor, ammeter. We use those very often for very large currents, or let's say we're in a factory and there's a cable that's carrying 200 amps and it's the size of my thumb. You don't really want to break that and put an ammeter in series with it. So you basically put a coil around it and you measure the amount of current and voltage that's being generated by that coil. So now we're going to measure ohms. We want to figure out what the resistance is of this resistor. Okay. Well, how do we measure what's Ohm's law again, everybody?
E
equals I times R.
That's right. E equals I times R. Okay. So if we have a resistor and it's a mystery value, how would we figure out what it was? If we had a test voltage, we could measure the current. If we have a test voltage and we get a current, what can we calculate? We can calculate our resistance. An ohm meter goes like this. Inside an ohm meter, though, what you actually have is this. That is what an ohm meter is. So the thing on the right is a battery. And what's the thing on the left?
Capacitor.
An ammeter.
That's an ammeter. So we have a test voltage, which is usually a 9-volt battery, and an ammeter. So we hook it up to our mystery device. We have a 9-volt battery. We can test this by putting a voltmeter across it. Maybe it has it in there. That way, when the battery starts to die, we're still accurate. So we have a voltmeter and an ammeter, and from that, we can calculate our mystery resistance. So now my question is, let's say that in addition to that, we have accidentally left this whole thing connected in another circuit. What's that going to do to my voltmeter? Let's go around the circle here and see what happens. We go this way and 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 this way. Current goes however it wants, right? Well, at the very best, we're going to get an inaccurate reading for our resistance. At the worst, what are we going to do?
Explode.
Blow the meter.
Blow up your meter. Yeah. So that's why it's really important to make sure that you use the right setting on your meter. For instance, if you have a multimeter and it has a volts and an ohms and an amps setting, make sure you pick the right one. Also, make sure that you don't put a voltmeter wired in series with your circuit, because that'll blow it up too. Done that. And fortunately, the meter that I have has an oops fuse built into it. So if you happen to be careless enough or just make a simple mistake, it will save the meter, but then you have to go to the store and buy a new 0.44 amp fuse. So, and there's only one place you can get those. Okay, so let's see. So voltage and resistance. You collect, okay. So you connect a voltmeter in parallel. You can connect an ammeter in series. If you're measuring, if you're attempting to measure voltage when using the resistance setting, kablooey. When measuring high voltages, you have to make sure that your leads on your ammeter and voltmeter, etc., are rated for that voltage. When I'm at work, I get to work with 480 volts. So has anyone ever been to Harbor Freight?
Yes.
Okay. Has anyone ever gotten a $3.99 multimeter at Harbor Freight?
Yes.
So have I. So it's a nice looking meter, isn't it? I mean,
It's very pretty.
it is. It's like a
It
red
does, you know, it
case.
does function.
Let's see how much it is today.
Uh,
There we go. Oh,
sometimes.
$7. Okay. But sometimes they'll be on sale for $3. Sometimes they'll even be free.
Yeah.
But you know, for measuring basic voltages, you know, even up to 120 volts, I'm okay using this meter. Nothing really bad's going to happen. For certainly for, you know, batteries, for little circuits, things like that, it's fine for that. What's a little scary is that this has a rating of up to 250 volts DC right there on the meter. It says 250 volts. I personally wouldn't do that. So for $7, this is what you get. Now, this is what I use at work. And notice what the price is on this meter. Everyone see that?
Oh,
521 bucks. Right? This is a Fluke 87. It's a digital meter. This is rated up to 1,000 volts. And it's a lot more accurate. It's still digital. It's more accurate, but more importantly, it's rated for 1,000 volts, and it's actually going to allow me with some confidence to use it at high voltage and not have it blow up on me.
Also built for daily use, so it
Yeah,
takes a lot of abuse.
That's true. I've had mine for 20 years and it's still great.
you're just taking the fun out of things now, Scott.
I know. Well, hey, but you know what? I have the Harbor Freight one. You know, I mean, that's in my car. You know, for just measuring voltages, testing little batteries and stuff like that. It's great. I don't need to have a $500 multimeter. Now, the other thing that a $500 multimeter will do that the $7 multimeter does not do is that, okay, let's say I have AC and it looks like this. That has a frequency. And remember, we talked about this thing called RMS voltage, which is that whole equivalent power generation capability of this thing. If I plug this in, if I plug my meter in to my wall socket, even though this is plus 170 and this is minus 170, it will say, oh, plus 170, minus 170. This is 120 volts because it's programmed to do that. That's how that works. However, if, for instance, I were to take either of those meters and instead my waveform doesn't look like that, my waveform actually looks like this. And it still has a plus 170 and a minus 170. My Harbor Freight meter, which is not true reading, it will say, oh, the peaks are 170 and minus 170. This is 120 volts RMS. But it kind of doesn't look like it anymore, does it? It's not really a sine wave.
Right.
If I were to do my expensive meter, it would actually analyze the waveform and say, well, this is 136 volts RMS. This is a true RMS reading meter. It's a lot more expensive. It's a lot more accurate, but it actually gives you more information on the thing that you're looking at. Okay, moving on. Let's say that you're charging up a, let's say you're taking a resistance reading on a circuit, and as you connect the power supply, as you connect the meter to it, the resistance starts off as 0, but then it goes up to infinity in a period of like 2 seconds. It's actually charging up a capacitor in the circuit. That's what that means. Because remember, an ohm meter has a power supply, usually a 9-volt battery built into it. The 9-volt battery is charging up a capacitor, which looks like which looks like a short circuit at the beginning, which is 0 ohms, and then it fills it up and it becomes fully charged, and then it can't take anymore. So your current goes to 0. So the meter is doing its best to calculate it. So it says at the beginning, oh, it's a short circuit. No, wait, it's an open circuit. So it'll make this, it'll make this curve. Okay, the two kinds of solder, there's rosin core and acid core. Acid core is used for plumbing. We don't use this on electronics because it'll destroy your circuit board. We only use rosin core. Rosin is a material that cleans as it melts. So it takes any oxide and it carries it away in the smoke. So if anybody's ever done any electronic soldering, there's that nice little cloud of kind of acrid, weird smelling smoke. That's actually burning rosin. It's the same stuff that you use on stringed instruments when you're rosining your bow. A cold joint means that that the solder didn't melt completely and fuse to the things that you're soldering together. It might be a mechanical connection, but maybe not a good electrical connection. And when things get colder, they will separate, and all of a sudden your thing will stop. The thing that you're using will stop working. That's called a cold solder joint. And again, we always use rosin core solder. Okay, here we go. Operating procedures. What type of station simultaneously retransmits the signal of another station? Everybody should know this one. We drew it up. That would be a repeater. Yep. Okay, so now there are actually 3 types of stations that automatically retransmit. There's a repeater. We know what a repeater is. An auxiliary station is a radio station that is designed to be a captive repeater, basically. It receives information and retransmits it, but it's not from the general public. It's essentially like a link in between 2 other things. That's an auxiliary station. And then there's a space station. A space station is anything 50 kilometers or higher in altitude. That actually falls under separate rules. So a space station is anything 50 kilometers or higher. So a weather balloon typically is not going to get there. A model rocket will typically not get there, but there are a lot of satellites up there, and satellites carry repeater stations on them. So that's actually a repeater on a space station. The International Space Station has a repeater on board. A linked repeater network, that's where you have multiple repeaters all connected via some backbone, either internet or radio frequency, so that when your signal gets received by one, it gets passed around to everyone and sent out on all of them. Here in Oregon, we have something called the Peak Radio Association repeater system. It's a system of 50 linked repeaters all around the state that go all the way from Idaho to California to Nevada to Washington, with Oregon in the center. And the nice thing about that is that all of those repeaters are at high locations all around the state. So no matter where you are, you can pretty much find one of them. There's even, if you're familiar with Oregon geography, there's even one on Steens Mountain at 10,000 feet. And that one covers all of Eastern Oregon and into Idaho and Nevada, which is an amazing thing. And if you can access any one of them, you can access all of them. and you can talk to anybody who's using any other one. So just using a handheld radio, it allows you to use the entire system. Common repeater frequency offset in the 2-meter band. All right, so we're going to bring up the 2-meter band. The 2-meter band is, let me see the picture again. 2-meter band is 144 to 146. Or 144 to 148. Here we go. This is something you're just going to have to memorize because you're going to be using it. 144 to 148. Notice that these have different colors. The orange areas are FM repeater. The blue is satellite. The pink is FM simplex. That means point to point without a repeater. And notice we have all the way here on the left end, this red, which says Morse code only down there. And the light green, SSB and weak signal, that's digital, Morse code, etc., etc., etc. No FM. FM tends to take up too much space. Okay, repeater offset in the 70 centimeter band. We haven't talked about 70 centimeters too much, but here's the 70 centimeter band from 420 all the way up to 450. That's a really big band, isn't it? 30 megahertz of space. The repeater offset is plus or minus 5 megahertz. You'll notice that the orange areas, 440 to 445, that alone has more bandwidth than the entire 2-meter band, which is only 4 megahertz wide, and 447 to 450. So there's a lot of room for repeaters up there. If you're going to build a new repeater, that's probably where you're going to have room to put it. There are a lot of frequencies available up there. There are very few frequencies available on the 2-meter band. Okay, we covered this. ETCSS, that's a subaudible tone along with normal voice. Let's say that let's say you're on a right repeater frequency, right? You know that the published frequency is 146.72, but damn it, nobody can hear me. I can't get a repeater squelch tail. So I'm going to, for instance, do this right here. I'm going to go and, okay, original sound for musicians. Can everybody hear this if I do this? Ready? N7JI. Could everyone hear the beep?
Yes.
And then the repeater ID. So that's basically the repeater then IDing itself using Morse code. Let's say that I know that there's a repeater really nearby and nobody can hear me, and I can't even get that little squelch tail or the ID to come up. The reason being that, okay, there's a couple of reasons for that. Number one, if I'm in a really terrible spot, well, but let's say I'm on a hilltop. I'm not in a terrible spot. If I have the transceiver offset set wrong, or let's say it's not set at all, I'm not transmitting where the repeater is listening for me. I could also have the wrong tone. There are 38 different tones that can be used, from 67 up to 253 hertz. If you have the wrong one programmed, you will be rejected. The same thing with DCS. There are dozens and dozens of DCS sequences. If you have the wrong one set, nobody will hear you. Now, we also run something called the Now What Net, which is a beginner's net. And sometimes we know that there's somebody who's trying to get into the repeater, but they, for some reason, can't for those same reasons. One thing we can do, most transceivers that use that do repeaters have something called a reverse function. This allows you to switch temporarily your receive and transmit frequencies and allows you to listen to people trying to get into the repeater. From that, you might be able to diagnose why somebody's having trouble accessing a repeater. You can listen on the input, as it's called. If your FM transmission is distorted, you could be talking too loud. So back off on it. As Kent said, Some of the newer radios actually have a microphone gain. An appropriate way to...
Your audio is starting to get kind of weak.
Okay, how about that?
Better.
Thank you. An appropriate way to call another station if you know the other station's call sign. Is there anyone here, anyone sitting in this room who's got their license? I thought we had at least one.
Yeah, I am.
What's
Scott.
Yes.
Kilo 2 Oscar.
You're KK20. Okay, and who else? I thought we had one other person.
K7EIO.
K7EIO, like EIEIO?
Yep.
Okay. Okay, so if I wanted to call K7EIO, I would say K7EIO, this is N7JI. And how would you reply?
Do you know how long it was since I took this the first time?
Nope.
A few years.
We got to get you on the air more.
I know. At
You would-
all.
You would just reply back to me. N7JI, this is. Go ahead.
No.
Yep, N7JI, this is K7EIO. So the station you're calling comes first, then your call sign. KK20, this is N7JI. Are you around?
N7JI Kilo 2 Oscar. Yeah, I'm around, and my handle is Randy. Radio amateurs never die young.
Okay, RANDY. Gotcha, Randy. Now notice Randy also threw in his name. He also threw it in using phonetics that's actually non-standard phonetics. If you know each other pretty well, you can do that. But we're going to get to phonetics, so it'd be Romeo Alpha November Delta Yankee, right? And mine, if I wanted somebody to know my name and how it was spelled, it would be Sierra Charlie Oscar Tango Tango. It's actually really useful in cases where you have let's say an interesting or odd spelling or a name that most people won't know how to spell. You want to make sure that, like for instance, Rich Friedlander. There's apparently I now know that there are two ways to spell Friedlander because my friend Judah Friedlander has no L-A-E. It's just L-A.
LAN.
Yep. So I would spell that out if I wanted it to be accurately received to make sure there was no ambiguity there. So that would be the use of phonetics. Okay. In order to identify that I was here and listening, I'd say this is N7JI listening or N7JI monitoring or N7JI listening on frequency or whatever it was so that basically somebody would know that I was there. Transmitting and receiving on the same frequency is known as simplex. Why are there simplex frequencies? Well, let's say that you and your friend are a quarter mile away. A repeater is, unless you want to actually be having a conversation that can be listened to by a lot of other people or joined in by a lot of other people, a repeater is a valuable resource. You can really only have one person talking at a time or two people talking at a time if it's a DMR repeater. So in the process of doing this, if you're on a repeater, you're essentially tying up the repeater. Again, it might be that you are intending for a bunch of people to join you, but if you're not, simplex frequencies are great for that. The national simplex calling frequency, for those of us who travel a lot and drive a lot, 146.52 is the national simplex calling frequency in the US and Canada. So you could be anywhere, and I'm always, for instance, monitoring. If I have a radio on, I'm always scanning through 146.52. And that allows you to like pick up somebody else who's driving down the road or somebody who lives in the town where you are. And I've actually had very nice conversations with people in Canada who say, this guy said, we don't get many people up here on the radio. I mean, it's in the middle of Saskatchewan, so that's not really surprising, is it? In the country in Saskatchewan. So had a very nice conversation until I drove out of range. HF operation. HF is what kind of frequency, everyone?
High frequency.
What are the frequency limits for HF? We're going to stretch those brains.
300 to 30.
3 to 30.
Or 3 to 30.
VHF is?
30 to 300.
30 to 300.
30 to 300, and UHF is
300 to 3,000.
3,000.
300 to 3,000. Yep. Okay, CQ means I'm looking for anyone to talk to. So if I go CQ, 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 this is November 7, Juliet, India, CQ. That means I'm looking for somebody. If you're hearing me and you feel like answering, I just left it open for you to answer me. Now, you would never call CQ on a repeater. So everyone here is probably going to be on a repeater at some point, and I'm just going to tell you now, don't do it because somebody will mention it. You don't call CQ on a repeater. It's not wrong. It's just procedurally incorrect because you know that there's a repeater there to talk on. So what you're going to basically say is this is N7JI listening. So I'm protecting you from the ire that you would otherwise get. What do you do before calling CQ? Well, first of all, you look at the frequency and you make sure you're even allowed to be there. Remember that whole frequency chart that we put up yesterday, which we can put up again right now? every different license class, notice that this says EAG, extra, advanced, and general. And then there's some other stuff which has a star, and the star says novice and technician. You can't get a novice license anymore, but you used to be able to. And there are still novice licensees. So notice that gives you certain privileges. You have privileges on CW, on the 40-meter band. So you find that, okay, well, I want to be operating on 40 meters. If I hear if I'm looking around and I see an open frequency on 7.012, first thing is, well, if I'm thinking about calling, I know I'm not allowed to be there because that's not in my block, that little green hashed block. It's very useful to carry one of these things around, even if you're experienced, post it on your shack wall. Okay, make sure that you're allowed to be there. Then listen, listen, listen. If you don't hear anyone, there's a good chance that nobody's there, but it's not a guarantee. Because propagation is such that we're going to draw a triangle. And here's the triangle. A and B and C. And I am station A. And I am listening on this frequency. And station B is in conversation with station C, and station C is talking to station B. Because of the weirdness of propagation, I have no way to hear station C. So as far as I'm concerned, the frequency is what?
Open.
Busy.
Open. Right, because I don't hear anything. So if I don't hear anything, the next thing I ask is the frequency in use? Well, station C can't hear me, but station B is listening to station C, and station B can hear me. So what would station B tell me?
This is in use.
Yep, sorry, the frequency's in use. Even if I can't hear who they're talking to. This kind of stuff happens literally all the time because propagation is just like that. There's a good chance you'll only ever be able to hear one end of a conversation. Okay, how do you respond to a station calling CQ? Okay, well, NN20, are you ready? CQ, CQ, CQ. This is November 7, Juliet, India, Eugene, Oregon, calling CQ.
Kilo 2 Oscar.
Kilo 2 Oscar. Good afternoon. This is N7JI. My name is Scott, Eugene, Oregon. How copy, over?
I copy you 5x9, loud and clear. Nice to meet you, Scott. My name is Randy in Aurora, Colorado.
Okay, thank you, Randy. And you're also a 5 and 9 here with absolutely no distortion and no QSB to speak of because we're using Zoom today. So pleasure to meet you. And I think I heard some other stations calling, so I'm going to go and try to get them as well. Have a good afternoon, Randy.
73s.
7-3. This is November 7, Juliet, India, calling CQ. So that would be how you would do it. And there's no reason to be overly nervous, although everyone here, I guarantee, will be nervous. How do you identify a test transmission? You give your call sign, N7JI. I'm speaking that into my microphone, watching what my transmitter does. Okay, QRM. Yeah.
Especially on that first contact that you make on your radio, you'll be a little hesitant to key it up, but don't be afraid. We've all started there at one point in time.
Yep. And at some point, you'll probably be panicking because you think, oh my God, I blew something up. I've done that. I've never actually blown something up, but I thought I did I've thought I did many times.
Oh, I've done that. I've blown caps out of my amplifier. So if you don't tune those up right, that happens.
Yeah, and I thought I blew up I thought I blew up the finals on my old Kenwood 520. It turned out that I just didn't know how to adjust the plate and the grid properly. Once I did, everything was fine. I also learned that if I'm on my little Yaesu 817, if I am using FT8 and I'm too high in the passband, I get no power out, which made me say, oh no, I blew the finals. But then I realized that I was just outside of the passband and the audio wasn't making it there. So there's a lot of stuff to this. And it's a great learning experience, and sometimes it'll cause you a great deal of panic. But don't worry about it. Most of the time, everything's okay. Okay, so on the air, yes.
There's a question in the chat. What is the reference for 5x9 or 5x5 notations made?
Oh, yeah. Okay, so signal reports. Okay, so on signal reports, you have RST, which is readability, strength, and tone. Readability is from 1 to 5. Signal strength is from 1 to 9. And tone is a subjective 1 to 9. Now, this is usually using Morse code because the tone is the kind of like the timbre of your signal. Most modern equipment, you'll get a 9 for the tone. But sometimes you'll hear somebody going whoop, 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 whoop. That's usually the sign of somebody's battery going low if they're operating off of battery equipment. And okay, so then maybe I give them a 7 for the tone. Sometimes you might actually have some AC hum on a transmitted signal. That would kill the tone. But then again, that's for Morse code. For voice, we usually drop the tone portion because, unless, you're not measuring how grating somebody's voice is. You're not trying to insult them by saying, oh, your voice is only a 4, because you smoke too much or something like that. So we drop the tone portion so they go 1 through 5 and 1 through 9. So 5.9 is a perfect signal report. 5.99 is a perfect signal report. If somebody is weak, that first R again is readability. They might be a 2x2. I've given somebody a 2x2. I've given people a 119 on Morse code, which means I could just barely read them and they weren't even moving my meter, but I could still copy them. So that's where the RST comes from, or the RS. So 5.9 is a perfect signal strength. Okay, good question.
Thanks.
Yep. Okay, so Q signals. Q signals are used as shorthand. They came about from telegraphy. And the reason that we use them is because there are a lot of things that would take a lot of words, and there aren't that many words that start with Q followed by a consonant. Right? If you think about it, QR. I can't think of many words that start QR except QR code. And that's, nobody does that, right? Or QS. Not many words start with that. QT. So there is a whole bank. If you want to go and for enrichment activity, you can look on Wikipedia and look up commonly used Q signals, and there are dozens of them. We use them for message handling, traffic handling, things like that. QTC, QNI. Most common ones are that we actually say in voice too is QRM. QRM means I'm getting interfered with by somebody. There's also QRN, which means I've got a lot of static crashes. There's a lot of natural noise. M is man-made, basically somebody, and N is natural. QSY means I'm changing frequency. And the nice thing about it, again, is that it's short enough and ubiquitous enough that you're going to say, I'm going to QSY to 10 meters. Everybody knows where you're going. A band plan beyond the privileges established by the FCC is a voluntary guideline for using different modes or activities within an amateur band. This band plan is not set in stone. The other thing is, you'll notice that, for instance, there is nothing that says channel 1, channel 2, channel 3, channel 4, channel 5, etc., on most of these bands. The 60-meter band is an oddball. We're going to ignore that one. But these bands don't have channels to set up. If I want to tune my radio to 14.322266509 megahertz, I can do that. All right? If I have essentially an infinite number of different frequencies that I can tune to. There's nobody saying you have to tune to 14300 and the next one is 14305 and the next one is 14310. You know, if you look at Citizens Band, you have 40 channels. Those channels are defined by 10 kilohertz increments. We can tune anywhere we want within those frequency edges. That also brings along a certain amount of responsibility, because if we can tune anywhere in that band, so let's say we're going to go from 14 to 14.35, the only rule that really is set in stone in the FCC rules is that all of your signal has to fall within that frequency band if you're on that band, which means that you have to know what your signal is doing. So if I were to draw the center frequency, here's my center frequency, which side would the upper sideband fall on? The right or the left?
Right.
The right side. This would be my upper sideband. Which side would the left would be on the left side?
The lower sideband.
Lower sideband. Okay. If I was operating, and this is about 3 kilohertz wide. If I were doing this and I were using upper sideband and I had my dial set to 14.348, here's my center frequency, where would my signal be?
You would be transmitting out of band.
It would be like that. Part of my signal would be out of band. That will get you an FCC violation, or at least hopefully you correct it and then it doesn't get you a violation. Hopefully somebody is kind enough to send you a note that says, hey, just so you know, during this contest, you were awfully close and some of your signal was spilling over the edge. If I hear somebody doing that and I get a call sign, I'll actually send them an email saying, hey, just so you know, you're out of band. It's better to hear from me than from the FCC. So that's why it's important to know, in addition to what you're doing, because we have that ability to have all that frequency agility, what you're actually doing, what your signal is doing. When two stations are on the same frequency, who has right to it? And the answer is nobody. You figure it out. If you've been on a frequency and you're using it and somebody else comes along, you can say, hey, the frequency is in use. Now, if they say, hey, you know, we're about to start a net in 10 minutes and we've got people from 17 states that are going to be joining, then you'd say to the person you're talking to, hey, let's move down 5 kilohertz. There seems to be an open frequency. Let's make room for the net.
Play nice.
Yeah. I mean, this is all, you know, a big family, and we're all going to need to work with each other at some point, so you might as well start now. Public service and emergency communications. ARES is the Amateur Radio Emergency Service. It's a group of licensed amateurs who volunteer their services and equipment for communications duty in the public service. That can be with state government. It can be with county government. It could be just a group that serves hospitals, things like that. Basically public service. RACES is actually a governmental organization that uses ham radio. So the difference being that ARES is voluntary, that governments and other organizations can use in times of emergency. RACES is actually signing up with a group that is orchestrated by your local government. They basically can serve a very, very similar function. So RACES is a Part 97 service for civil defense communications during national emergencies. Again, there's a lot of overlap between what they do. The main difference is that RACES is actually run by governmental organizations. ARES is not. A net control station. Net control is net is short for network. Net control station is the station that basically serves as the traffic cop. So let's say that there's a power outage in your area. Everybody's on handheld radios. The net control station, a net forms, or you might be a scheduled net, like every Tuesday. So the net forms up. Net control station says, "Okay, I'm opening the net. Do we have anybody who wants to check in?" Let's go ahead and do that. This is N7JI Net Control looking for anybody who'd like to check in. Please come now.
Kilo 2 Oscar.
Okay, Kilo 2 Oscar. What's the name there?
Name here is Randy.
Okay, Randy, KK20. I've got you on the list. Please stand by in case there's any traffic. Any other stations would like to check in?
K7EIO.
K7. Okay, what was the call sign phonetically, please?
Kilo 7 Echo.
This is why we practice.
What's that?
This is why we practice.
Yes, which I haven't done for a few years. So, remind me.
Echo India Oscar.
Echo India Oscar. Thank you.
Okay, K7 Echo India Oscar. I've got you on the list. What's the name with there? What's the name with that call sign?
Annette.
Okay, thank you, Annette. And also, when turning control back to net control, please give your call sign and say back to net control.
Copy. K7EIO, back to net control.
Okay, thank you very much. Do we have any other check-ins? Please come now. Okay, nothing being heard. We'll go to KK20. KK20, do you have any traffic for the net? Over.
No traffic at the current time. Thanks. KK20 back to net.
Okay, thank you. K7EIO, any traffic for the net? Please come now.
No current traffic. K7EIO, over.
Okay, K7EIO, thank you very much. Everybody just please hold on. We're going to keep the net active, and we'll shut it down when the time comes. And if you have any emergency traffic, please break the net with your call sign and say with traffic, and I'll take your traffic at that point. Other than that, everybody just please stay on frequency, and we'll go through another round in a little bit. This is N7JI Net Control. And that's basically how you run a net. That's how you participate in a net. A net is a formal grouping of hams who get together to practice for fun, and practice makes perfect, so that when the time comes, you're actually able to know what you're doing. Okay, so notice that the other thing is very little chit-chat. So call the net to order, direct communications, and unless you're reporting an emergency, you transmit only when directed by net control. Because only one station can be transmitted at any given time. So we don't want to block up the frequency, because if we're chit-chatting, we might be blocking the ability of somebody who has an actual emergency to do that. Now, at the end, I'd say, okay, well, no traffic. The emergency is over. I want to thank everybody for being a participant. This is N7JI, formally closing the net at 11:41 a.m. Pacific time. The frequency is returned to regular amateur use. Thank you, everybody. Have a good day. So now, hey, KK20, this is N7JI. How you doing, Randy?
N7JI, Kilo 2 Oscar. I'm doing okay. Still have my 4 inches of snow out of the 6 inches that we got over the weekend.
So, Randy, I wonder if you can hear K7EIO. You want to try calling her? Over.
Roger that. K7EIO, this is Kilo Kilo 2 Oscar with N7JI. How do you copy?
This is K7EIO, N7JI, and Randy, I forgot your call sign already. I copy. K7EIO, over.
Okay,
Roger on that. Roger on that, K7EIO. The call sign here is Kilo Kilo 2 Oscar, KK20, and name here is Randy. Romeo Alpha November Delta Yankee. I about said my own a funny way of saying that, but definitely I've gotten accustomed to that too. So back to you, Scott. N7JI Kilo Kilo 2 Oscar with K7EIO.
Hey, thanks everybody. And okay, so now what we've basically done is the net is dissolved. Notice that it's a lot less formal. We're just having a conversation now. And this is what happens when you're just on the air. You know, you just have an easygoing conversation between people. A net is formal. Just having a conversation is just having a conversation. So we get people, for instance, who check into nets locally and here in Eugene, and they're all, very, very nervous and very stiff about things and don't really know what to say. When you're having a chat on the radio, the FCC rules say that there are certain things that you can say. The only things you really don't want to talk about are religion and politics. And beyond that, I used to laugh because I got my license when I was 15 and I turned on the radio and I'd hear people talking about their doctor's appointments. And the sciatica hurts so much. I can't believe it. But I got a doctor's appointment on Tuesday and maybe I'll get a cortisone injection. And I would just think that was so funny, except now that I'm almost 55 and I know exactly what they were talking about. That is perfectly legitimate stuff to talk about, as is, where are you going out to eat today, whether you like a restaurant or not, what's happening with your car, what happened back in the 1987 World Series. There's an infinite number of things to talk about. This is a chance for people to, essentially ham radio is a very social hobby for people who are very social. Not everybody is. For those people, it's great that there are digital modes. It's great that there's Morse code because you don't have to talk. But some people just really like talking.
Hey, Scott.
Yeah.
Are you going to get into phone patching through this course or not?
I can very briefly talk about it, but phone patching is kind of, it's sort of gone by the wayside. But we can bring that up. Essentially, I'll do that when we get to third party.
Okay, thanks.
Is that okay?
Tina, did you have a question?
Yes. I used to work in corrections and we used the radios every day.
Mm-hmm.
And specific rules, we were told that we would be fined by the FCC if those things happened on the radio. And so one of those was cursing.
Yep.
Is that for everyone, or was that?
That is for everyone. That is a general rule from the FCC for all over-air communications, except for cell phones because it's encrypted.
Or using slang things to describe.
Well, we'll get to that.
Okay, I just want.
Okay. Okay. Traffic. Traffic is information that goes from one point to another in a net. So during the formal version of the net, the formal portion of the net, if Randy had traffic for K7EIO, a net, he would say, this is KK20, I have traffic. And I would say, okay, who's your traffic for? And he'd say, my traffic is for K7EIO. And he would either hand it to me and I would repeat it, or if I knew that they were in mutual communications distance, I could say, go direct with a net. So basically, the net control is the traffic cop. Traffic is information being exchanged. Good traffic handling means that you don't lose any words or letters or anything like that. Anything that is an odd spelling, or you want to spell out a street name of where to report, In Eugene, we have Hilliard Street and Hilliard Street. One is Hillyard and the other is Hilliard. Really, they're pronounced the same. So you would probably want to, if you know that there are two of them, spell that out phonetically so that the person goes to the right street. Information contained in the preamble of a formal traffic message. Information needed to track the message as it passes through the system, because it's going to be handed off from person to person. The check in a radiogram header. A radiogram is basically what it sounds like. It's kind of like a telegram, but over the radio. The check is the number of words or word equivalents in the message. So, I am going to the zoo, right? You can send something as mundane as that. I am going to the zoo. Six words. And the check is 7. Uh-oh. There's something wrong. Well, the check is 7 and I only got 6 words. What I really sent was, I am not going to the zoo. So by missing a word, we now know that the check didn't match and we need to get a repeat because something got lost. And it actually changed the entire message. When do FCC rules not apply to the operation of a station? The answer is never. The FCC rules always apply. Now, the question is, when are you allowed to transmit outside of your frequency privileges of your license class? That might actually mean that if you need to, you transmit on CB, you transmit on the fire frequencies, you transmit you transmit on the FRS frequencies or a police frequency. If you have a radio that's capable of doing it, you better be able to justify that there is immediate safety of human life or protection of property. There's a fire coming. It's right across the street from my house. Oh my God, please help. Somebody is about to fall into, off of the dam, right? They're hanging from a rope. That would be justifiable to get anyone's attention. There's a huge flood wave coming because the dam just burst. Get everybody out of town. If you can't use the phone and nothing else works, you can use any means at your disposal. Now, if you use any means at your disposal and it means transmitting somewhere where you don't have privileges or it's a totally different band, you're going to have to justify doing so. There was actually a story a couple of years ago now where there was a wildland forest fire in Idaho, and there was a ham who lived in that area, and he got the idea that he was going to talk to the wildland firefighters and direct them into where to go and fight the fire. He could have just as easily used the telephone. There was no imminent danger to his house or his property or him or anyone else. He thought he was going to help. He actually got fined $38,000 because he transmitted on frequencies he wasn't allowed to, and could have, in the process of doing so, tied up a resource that was being actually used for potentially saving lives because they were fighting wildland fires. So that is not to be taken lightly. Amateur satellites. We have many, many, many dozens of satellites flying overhead all the time. A lot of them are ham radio satellites. So the International Space Station, it's over 50 miles up or 50 kilometers up. Therefore, it's a space station. When are you allowed to contact the space station? You're allowed to, if you have a technician class license or higher, and you're transmitting in a band where you're allowed to transmit. Now, interestingly, if you're transmitting in a band where you are allowed to transmit, it's always okay. Now, let us say that a repeater station on the ISS, so here's the ISS, and you are transmitting on the 2 meter band, and they have it set up so that it's actually downlinking on 15 meters. The ISS doesn't have the capability to do this, but there are other systems that do. You are legally permitted to transmit on 2 meters as a technician. However, you are not allowed to transmit on 15 meters. Somebody's listening might hear your call sign popping up on 15 meters, but you did not put it there. That's still okay. In other words, it was retransmitted. So it might be confusing that somebody with a technician license would suddenly appear on 15 meters, but it's perfectly legal because it was another station that moved your voice to that frequency as part of the retransmission. UV mode is just like what it sounds like. It's UHF up and VHF down. The most common frequency is 70 centimeters up and 2 meters down. The International Space Station, I believe, operates in, yeah, they operate UV as well. No, they operate VU. Let me think about that. Yeah, they operate VU, so it's VHF up and UHF down. But that's what that means. It's the uplink, downlink. Amateur radio satellites, most of them use FM, but not all. There's actually Morse code over satellites, and there's actually single sideband over satellites. The advantage being that FM suffers from that thing that we talked about briefly yesterday called the capture effect, where only the strongest signal wins. And if there are two equal strength signals, they obliterate each other completely. Single sideband and Morse code and data, because they're based in AM, you can have multiple signals at the same time and still be able to hear both of them.
That's when you plug in the dilithium crystals.
Yes, exactly. But you have to say it right. It's dilithium crystals. Yes. Captain, I'm giving it all I can.
Fascinating.
Yes. What is the impact of using excessive radiated power on a satellite uplink? Well, if you're essentially flooding a satellite receiver with your signal, then nobody else can hear you. If there's a beacon coming out of the satellite and you can actually hear your own signal, which is kind of a trip, by the way, to hear your own voice being bounced off of a satellite. If there's a beacon, your voice should be about the same amplitude as the beacon. A beacon is the information coming out of a satellite indicating, like, for instance, where it is, how high it is, what the onboard temperature is, what its call sign is. It's basically just information. And because it's just being transmitted for everyone, anybody can receive it independent of whether you have a license or not. Low Earth orbit has the acronym LEO, L-E-O, low Earth orbit. Low Earth orbit satellites versus medium Earth orbit satellites versus geosynchronous or geostationary satellites. Low Earth orbit satellites, because they're typically only a couple of 100 miles up, they are moving really fast with respect to the ground. For instance, the ISS is passing. Has anyone ever seen the ISS pass overhead at sunset? It's pretty cool. Mm-hmm. Now, when I had one of those, I actually made a contact with somebody using the ISS by seeing where it was and aiming my antenna at the dot. And I was able to make contacts through the ISS repeater that way. I didn't even have to track it. I just could see where it was, which was really cool. But that whole process of it moving at 17,000 miles an hour has an unexpected, creates an unexpected challenge. The unexpected challenge is that, has anyone ever seen or heard a fire truck coming toward them and then passing them and going away? What happens to the tone of the siren when it passes you?
Doppler?
Yeah, it's Doppler. It goes from high pitch to low pitch. And that's because it's moving at a significant fraction of the speed of sound. Well, okay, that doesn't really work with radio, or does it? If I have something that's moving at 17,500 miles an hour, and the speed of light is a lot bigger than that, and I'm down here on the ground with my radio, and it's coming toward me at 17,500 miles an hour, it gets over my head and then goes away from me at 17,500 miles per hour. What ends up happening is, if they are transmitting on 437.800 megahertz, I will hear them at 437.805. And on the other side, I'll hear them at 437.995. And that is because the radio waves are actually getting stretched and compressed by the thing moving toward and away from me. At the same time, when I'm transmitting to them, if I know they're coming toward me, I have to intentionally transmit low. And as they're moving away, I have to intentionally transmit high. And this is known as Doppler. It's the same thing that you experience when you're dealing with, same thing you experience when you hear a fire truck drive by. Okay, a satellite beacon, again, is all the information coming out of the satellite. Health and status of the satellite, location, temperature on board, battery power, battery voltage, things like that. Telemetry from a space station is all the information that comes out of the beacon from the satellite. Anybody can receive it because it's meant for everyone. Satellite tracking programs tells you basically if you plug in the orbital elements known as the Keplerian elements for that satellite, it will tell you at any given time where the satellite is and where it's moving and how to point to it from where you are on the Earth. Very cool. Very, very, very much easier than trying to figure it out just by guessing. Besides the fact that they're moving really fast. We talked about Doppler. Spin fading. As a satellite rotates in space, in order to maintain stability, the satellite antennas will move sometimes away and sometimes toward you, and sometimes they'll disappear from view. Well, when they disappear from view, they're pointed the wrong way, and you get this thing called spin fading. All right, operating activities. Making as many contacts as you can in a period of time is known as contesting. This is one of my great loves on the air. I like it because I'm kind of an adrenaline junkie when it comes to that. I like to push my own limits of what I can do with my equipment and with my own mind and what I'm capable of. And from year to year, I like to see if I get any better or unfortunately worse at certain things. So that's known as contesting. If you are in a contest, if you want to participate, you look at the rules of the contest and figure out what you send as far as information. If the contest exchange is your signal report and where you are, like a state, if it's somebody you know really well, maybe you talk to them for 30 seconds. If it's somebody you don't know really well, then you say, this is N7JI, you're 59 Oregon. And they'll say 59 New Jersey. Like, thank you. Next. Because your goal is to make as many contacts as you can in a short period of time. There's always time for chit chat later. A grid locator, the whole world, and this I actually sent out a grid map as part of the packet that I sent out. Let me see, grid square map. Yes, I did. Can everybody see the grid square map?
Mm-hmm.
Okay, so if you know where you are on this map, you can figure out what your letter, number grid identifier is. So I'm in CN84. Claude, where are you on this map?
Lynchburg, Virginia.
Okay, where is Lynchburg, Virginia on this map?
It's in central Virginia, about, what is that, 07?
So that'd be Fox FM 07. The reason that we do this is that these squares are 2 degrees in latitude by 1 degree in longitude, and they allow us to point the antennas a little more accurately. For instance, look at Montana. Montana has 12. Montana's got about 24 grid squares that are part of it. If you're in Idaho and you're aiming toward Montana, where in Montana are you aiming? Well, you could be aiming due north or you could be aiming due east. So that allows us to get a little more granular as far as pointing antennas. And on top of that, each one of these grid squares is split up into a 24 by 24 subgrid. So I know that I'm in CN84LA. If I'm operating at a very, very high microwave frequency, where if I'm 2 degrees off in pointing my antenna, nobody will hear me, then knowing that exact grid is really important. So that's called a grid. That's called a grid locator. Sources of noise interference or jamming. We use radio direction finding. That's a directional antenna that we point in one direction and we peak the signal. There's a sport which we do called fox hunting, or in some cases we call it bunny hunting, where we basically look for a hidden transmitter in a park or in a city, and you walk around and you take beam headings and figure out where the antenna signal is strongest. And then when you get closer, you decrease the gain of your radio, and hopefully you can figure out exactly where it is. We make a sport of that. It's good for finding sources of interference, whether deliberate or not. Okay, so the Internet Radio Linking Project. John, are you here now? John, I thought I saw John. John.
Yep, I'm here, Scott. Just needed to unmute.
John, we missed you this morning, but
sorry. Can I fill in now if you'd like?
Yes.
Sure.
Okay, so we're talking about IRLP, voice over internet, Echo Link, and what a perfect segue. So
wonderful.
John is one of our digital gurus who I asked to drop in. And does anyone want to take a 5-minute break before we do that? Stretch the legs and stuff?
Yes, please.
Okay. John, we're going to take a 5-minute break. Okay.
Sounds great. I'll see you in 5 minutes.
So, John, what was the weather like at the coast this week?
I hardly ever saw the sun, so it was overcast virtually the whole time. Some periods of rain, never torrential rain, and actually relatively little wind, although
really
it was a king tide. And
I did hear that. Karen sent me some pictures.
It was amazing. Everywhere you could see the ocean. There were just major waves rolling in, one after the other, crashing on rocks and doing just a tremendous display of fury. And in some of the places I camped, it was relatively close to the surf, and the ocean roared all night long. So,
really?
Yeah, really. Very typical Oregon weather. I would not say I found there were no storms. One rain kind of strong for about 3 hours came along and then disappeared. That's very different from a couple of weeks ago when we went out there and there was that atmospheric river.
Oh, yeah.
And that was amazing. If you really wanted rain,
that was it.
That was it. My RV does not leak.
Well, so it's been tested.
Yeah. How long have you been a VE, Scott?
Since 1986.
Man, that's great.
Well, I guess I applied in 1986 and it came through in 1987. So a while.
1987.
Yeah.
Holy cow.
Yeah. So what, 36 years?
Yep. That's the year Nathan was born.
Actually 37 years, because it was January of 87. So
back in Maryland.
Yeah.
Yeah.
That's
All
one
right.
of my that's one of my reasons why I want to try to get back in active is I was a W5YI VE, and I'm wanting to get back into the amateur radio world stuff to become more active and become another VE as well.
It's a worthy ambition, Randy. That was you talking, right?
Yeah.
That is correct. Yes.
Yeah. We have several. Scott and I are part of the same radio club here in Eugene, and we have several VE people who are certified as VE testers.
We've got about 20.
Wonderful.
Yeah.
We have 20.
About
yeah.
20.
Well, the nice thing about that is we do tests once a month, maybe twice a month, and we will even meet people at their homes if they have a mobility issue or anything like that. And the nice thing about having so many VEs is, well, not only is every testing situation a social event, but we can do the test no matter what. So VE can be out of town or whatnot, and so he has such a good pool to draw from.
Yeah, and of course, with remote testing, you heard Kent talk about all the remote stuff. I started doing remote testing right when COVID started. The Alaska group needed to do remote testing just because Alaska is so big, so they applied for that. He said back in 2014, but when COVID hit, the groundwork was already there to do remote testing. So, if somebody's got a US ID or something, it doesn't matter where in the world they are. They said they've tested people who were in Kuwait, they've tested people all over Europe, Japan. So long as they've got an internet connection. Africa. All right, so we're going to do the digital part of this, and so like I said, this is John. It's actually a perfect time for you to drop in.
Great.
So
Great.
So John, if you want to, and everybody, if you've got any questions, this is a really good time to ask about digital mobile radio, voice over internet protocol, gateways. Something called Arden, which is Amateur Radio Emergency Data Network. Did I get that right?
You did.
Okay. So
yeah.
So John, you see right on the page, we're kind of sticking with this. So IRLP, VoIP, etc. Go ahead and take a look at the page and see.
All right.
So start with IRLP.
IRLP means Internet Radio Linking Project, if I'm not mistaken. It is one of the very first methods used in the digital radio space. It was designed to link repeaters. I'm sure Scott has talked to you about using repeaters where a handheld radio can communicate much farther than normal radio to radio simplex using a repeater tower. Although ham radio operators love to experiment and expand, and repeater owners were interested in linking up their repeaters together so that your voice could reach much farther than just what we call the footprint of your nearby repeater. In fact, there are systems that are linked completely up and down the West Coast or large swaths of the Midwest or up and down the East Coast. I know of one system out here on the West Coast that has almost 45 to 55 50 repeaters that are interlinked. So when you tune to any one of those repeaters and you key up and talk, that signal is shared across the internet and reappears and retransmits on 49 other repeaters, and all the different people listening to those repeaters can hear you and respond. Typically, people are very courteous on these systems and don't talk for long periods of time because they're so large and interconnected. So IRLP was one of the very first modes that did this. Back a long time ago, repeaters tended to be connected together using microwave dish antennas from point to point. And then recently, with the internet, I'm getting old now, ham radio operators figured out ways to interconnect the repeaters using the internet. And IRLP is one of those. In addition to that, although IRLP is typically just a repeater domain system, only the repeater operators play with IRLP. However, there came a need for regular ham operators like me and you and Scott to use the system when they were traveling. So along came a technology called Echolink. And very soon thereafter, another technology called All-Star. Echolink and All-Star do exactly the same thing, so I'm just going to refer to it as Echolink. Echolink is either a piece of software you install on your PC or your Mac, or an app you install on your mobile phone, which allows you to link to a variety of repeaters worldwide. You can do that if you want to reach out and talk to a friend, or you can simply do it for entertainment just by linking to a distant repeater and just listening. There's no reason you can't do that. There are a variety of web pages that you can go to find out where all the talking activity is if you just were interested in listening to conversations. Now, IRLP, Echolink, and All-Star are what we call analog voice connection systems. They don't specifically, there's no digital traffic that goes over the airwaves in these systems. Yes, your voice is digitized so it can go across the internet, just like any telephone call or cell phone call is these days, but it pops out the other end in analog form. So a lot of people like it because it's familiar with the typical analog quality.
So can everybody see this that I have up on the screen?
Thanks for showing that, Scott.
Yeah, this is Echolink on my computer. And to answer the question, if you live in a metroplex, you don't have room for an antenna, or you're traveling somewhere, this is a list of all of the Echolink connected repeaters as well as individual stations. Like there's Nathan, AI7NC. Then that's just in the 7th region. Now there's the 0 region. There's the 3 region. There's the 2 region. These are all different
and
parts
international
of the country.
too.
And
yeah,
lots of international stuff as well. If you take a look at Europe, oh look, I was just in Finland. Look at all those different, Kouvola. I was in Kouvola just about a month ago. So I could actually dial that up. Notice it says -R. That's a repeater. If I knew that there was another ham there, I would just use my call sign and be talking to people on a repeater in Kouvola in Finland. I could also pick another country and do the exact same thing. And in fact, this OE5, where's the OE5? Kaisersburg, Linz, maybe it's OE3. Well, there's Vienna. There was a repeater. Oh, there's Graz, where I was actually in a town where I was actually staying. And when I left and came back to the States after working there, I got on the repeater and talked with the friends that I made back over there.
Oh, when you came back
when
home,
I came
you
back home,
reconnected.
Yeah,
Neat.
over Echolink.
Yeah. These systems are interlinked systems, and so radio operators need to have a little more patience when using the system. You cannot key up really fast, and it's a good idea to allow about 4 or 5 seconds after you finish talking to just let the system settle down and everyone have a space and time so that they can key up and communicate with you. Unlike a local repeater where you tend to have much more rapid back and forth. There are many other digital modes that I want to just briefly touch on. There are some, I'll call them pure digital modes: DMR, D-Star, Yaesu Fusion, and P25 are some examples. None of these.
We've kind of discussed DMR Fusion and D-Star as the Betamax versus VHS.
Good way to put it. Good way to put it. But in these modes, your voice is actually carried over the airwaves in a digitized format, not in the traditional analog FM format, which means that your transmitting radio has to be able to encode, and the receiving radio needs to decode. And then, of course, the speaker produces a simile of your original voice. And the quality of digital communication tends to be a little less in terms of just its presence and audio quality. However, there are advantages because the signals tend to be purer when you get out towards the fringe of your radio communication range.
Is there any error detection or correction?
There are some error corrections and packet loss concealment technologies whereby if a series of packets cannot be properly decoded, the radio does its best to kind of fill in, and it can. I'm sure we've all heard that on our cell phones once in a while. It sounds very robotic. There's not much of the error correction in the voice form, but when I'll talk about digital forms, there's a great deal of error correction available. So like these digital modes, DMR, D-Star, etc., often support what are called talk groups. Different technologies refer to them as different things like reflectors, etc. And these can be considered as conference rooms if you want. And there are great amounts of organization available. So every state, every region, every large city has their own unique talk group. In fact, there are worldwide talk groups, which are pretty fun to listen to. You hear people saying hello and trying to reach out and become friends to people. That's kind of fun.
And what's interesting also is that a lot of these little handhelds, the DMR handhelds, will have like 200,000 memories.
Right. So they actually will display the name of who's calling, and they will display typically the city, country, and state that they are calling from. These systems do allow you to make what I'll call person-to-person calls, where if you know the person's ID code, you can key that directly into your radio. The radio and the system that's behind it, all the servers, very similar to a cell phone, will know which repeater to activate. So I'm in Eugene, Oregon. If I keyed in the code for someone in Florida, St. Petersburg, it would know not to light up all the repeaters in the entire world, only the St. Petersburg repeater, because that was the most recent location that you transmitted on. So the system keeps track of your radio by which repeater is nearest.
Can everybody see the ridiculous number of DMR talk groups that exist out there?
Oh, yeah.
and a simple DMR handheld can basically access any of these. I mean, that's what they're there for.
So Repeater Book is a wonderful place to go to find a repeater in your local area. And I use it all the time. It's available on a website, and it's also available on an app on your phone. So I strongly encourage you get to know Repeater Book. And it will also tell you if a repeater has these digital functions available.
Yeah, and interestingly, I can bring up that when we are doing the exam session, you may notice that some of your examiners have a handheld radio next to them, and they are talking to each other, even though we are all over North America. We even have one of our examiners, I believe, who's in India, and I don't have a DMR hand. Well, actually, I do. I probably should get on. I probably should get on board. I just haven't programmed it yet. They actually are all on a DMR talk group, and that's how they talk to each other during an exam.
It's just like a conference call.
It's a very distributed repeater system.
Mm-hmm.
Yeah.
Yeah. And you probably notice, Scott, how you kind of just have to take a deep breath and kind of slow down compared to a local repeater. Yep. Moving on, in addition to carrying voice, digital radio can also carry data, which is, in my opinion, a very fascinating part of the hobby. My specialty is the fusion of computers and radio, and carrying digital data is one big part of that. But you'll want to ease into it. If this is an interest area of yours, you're going to want to start playing around with things that are basic, like having a chat between two radio operators using your keyboard would be a very basic way of getting into this. There are a variety of technologies. One is called RTTY, radio teletype. It is an older form. There's Packet, which is much more modern and runs at about 1200 baud. There are even faster methods and technologies. You will probably hear about VARA, V-A-R-A. I know you will hear about that as time goes forward. It's very doubtful you'll be tested on it.
You won't.
In fact,
it's too new.
It's doubtful you'll be tested on anything I'm saying, which is really awesome. You can just sort of kick back, and this is the fun part of ham radio. So VARA and VARA chats are much higher speed systems. They take more bandwidth in the spectrum, but the advantage is, of course, you can get data to flow faster. There's an entire ecosystem called WinLink that supports the sending of digital information using structured forms. So if you're ever interested in emergency communication, supporting your community through CERT or working with agencies like hospitals, police, fire, etc., or disaster management people, they need to have information shared in extremely structured ways to help manage the onslaught of information that happens during crisis events. And WinLink is a method that has been approved by not only ham operators, but also the agencies that would consume that data.
Virtually all of them are good with it.
Yep. It's a wonderful, wonderful thing to train on. And WinLink data can be sent over a wide number of, we call them paths or technologies. You can use radio, you can use internet, you can use microwave. You could almost use hand signals if you want.
John, did you see a note there about an NEAMA stream? Do you know what that is?
NEMA. NEMA. No, I don't.
Laura, you're going to have to explain that.
So a NEMA string comes from a GPS unit. And so I know that a lot of off-roaders will connect the GPS unit to their ham radio to broadcast while they're off-roading.
Right. I'm going to get to that in just a second. You're right. Now I know what you mean by NEMA.
John, so
I thought it was a NEMA enclosure she was talking
John,
about.
yeah, John, you've got a 3-minute warning.
3-minute warning. Okay. So you can text back and forth. Another thing is this thing called APRS, Automatic Packet Reporting System. A lot of hams like to fly balloons up in the air, and this system is used to automatically track the location and see it on a map. You can put a device in your vehicle that will link up with the GPS satellite system and publish your location on a map. If you were here on the break, you heard I went over to the Oregon coast and I was tracking my entire trip to the coast. And this system APRS supports text messaging and telemetry. If you happen to be a electronics engineer, or you just need to communicate some telemetry, let's say a battery voltage or a temperature or air pressure or direction, the APRS system supports that. And AI7BQ-9 would have been my track out to the coast, and you would have to put a track show a few days, maybe 4 days, both the track and the show last. We'll give my route. Now I haven't moved in the last 1 hour, so those will have to be.
I asked for it to go 6 days. Okay, keep going.
Yeah, and so and moving on, we have a microwave mesh network system, which is just you'll have to click search, I think, in the upper corner. Yep.
I said show all.
Yep.
Yeah. Look at that. There's John's travels.
Yeah.
Yep.
In the red line, and there are ways to get rid of all those weather station markers and things like that. But Arden, AREDN, Arden Mesh Networking System is, I'm going to call it a parallel universe to the internet. It is not the internet, but it is a TCP/IP network that ham radios operate. There are, oh my gosh, there are 300 stations in the state of Oregon alone. There are other hotspots like the Bay Area and Los Angeles and places out near New Jersey and Florida have very, very active systems. I happen to be very active in this. I run a series of telephone exchange systems where we can attach IP telephones to the system and talk to each other using just what looks like a standard touch-tone telephone. I am active in installing these systems in area hospitals and getting agencies on board with this high-speed communication system. In addition to voice, it will carry all the normal stuff you would expect on an internet, which includes sending photos, real-time chat, a variety of things. Now, you probably know from your studies and tests, you cannot obscure.
We're not there yet.
You're not there yet.
That's in the next half hour.
Please do.
That's why, John, we got a 1 minute warning.
And thank you. And finally, another piece of it is called FT8 and a variety of other technologies that allow people to get a good judgment of how far their signal is going, whether that be across the United States or over the oceans or into Europe or open over the pole. A fascinating website called PSK Reporter, which Scott's showing you right now. It gives a really fascinating view. If you're new to ham, one of the very first things that's on your mind is, can anyone hear me?
Yeah.
No one's responding. So you go to this system and it will tell you how far your signal is actually getting out there. And the only reason no one's responding is maybe they're eating dinner. They're not near their radio. And so,
like in the case of last night when I was on 160 meters, this is hopefully the map of that.
But it uses a digital system in order to encode your call sign and a central server to then if you're running that software, then every signal you hear is reported back to the central server so that your ears can help other people's transmitters and find out. That's called spotting. Yep. And that's really it in a nutshell. I'm available if anyone has any questions.
And you can contact, you can, John, can I give them your email address should they want to
Yeah,
contact
you
you
sure
directly?
can.
Okay.
Yeah, you sure can. Why don't you give them QRZ if you don't,
Okay.
if you're telling people about that, then they'll know a little bit more about my background.
Okay. Anybody got any questions about the digital realm? Don't be overwhelmed. It's a lot of cool stuff. remember when I started, I think I said this is not your grandfather's ham radio anymore. Your grandfather's ham radio still works, but as technology has changed, ham radio has adopted and adapted.
And as Scott is so well known for saying, Morse code was the very first digital code.
Yes, it was.
And it wasn't
180
even
years ago.
It wasn't even tones. All they could do is turn the transmitter on and off back then. But it was, and when I got my test, one of the very first things Scott cornered me and says, you need to learn Morse code. And I did, and I'm really, really glad that I did. And Scott's a great Morse code teacher.
All right, we're ready to get back to
thank you, Scott.
Rules
Thanks,
and regs.
everyone.
John, thanks,
Thank
man.
you.
Thank you.
Thank you.
Okay, and John, you can hang here or you can go either way.
Cool. Thanks.
Okay. The agency that regulates and enforces the rules in the United States is the FCC. If you go to Canada, it's a different organization. So, because I think everybody here is in the United States, they're all going to deal with the FCC. The basis and purpose of the amateur service. Okay, so this is a good opportunity to bring up the FCC rules, Part 97. Part 97 lists 5 reasons why amateur radio exists. One of them is advancing skills in the technical and communication phases of the radio art. That just happens to be one of the 5. I'll bring up some more of the 5 in a minute. A beacon. Hello, 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 hello. Not expecting a response, just saying, hey, I'm here. If you hear me, that means that there's a communications path between us. And it means, hey, I can hear Las Vegas. Okay, well, if I can hear Las Vegas, that means I'm going to call and see if there's anyone in Las Vegas that can hear me. A beacon is used for propagation or for experimental activities. Space station is anything 50 kilometers or higher, which we covered. When are you allowed to willfully interfere with another station? That doesn't mean accidentally. Accidentally sometimes happens. But willful, this guy's really pissing me off, and I'm going to just key down on top of him. You are never allowed to do that. Okay, a volunteer frequency coordinator. Okay, so a frequency coordinator is somebody who has been selected by repeater owners or those who are able to be repeater owners in a given place, like a state, who have taken on the responsibility of saying, you know what, people seem to respect me and they're going to trust me to do all these coordinations in our state. So there's band plans. So let's look at a band plan. So here's in Oregon, the Oregon Region Relay Council. This is the frequency coordinator for Oregon. Every state's got one. It sets up what bands are used, what bands are used in what way. Notice it's published coordinations. You cannot just go willy-nilly putting up a repeater somewhere because somebody else might be using those frequencies that you want to use or thought were free. Now, the repeater coordinator will also say, for instance, okay, 147.62. Let's take a look. 147.62. This is the repeater, W7PXL, of which I am the trustee for the Valley Club. Notice this other one, K7RPT in Astoria. That's a good 150 miles by air, right? Now, there are times that that repeater and our repeater can end up interfering with each other. Well, you'll notice that they're physically separated. Somebody in Portland could actually possibly work both of us in order to keep those from happening, in order to keep somebody from lighting up both of them at the same time. These will typically have different PL tones. Notice that there is no repeater in Eastern Oregon, which is on 146.72. It's entirely possible that that is an open allocation. that if somebody came along and said from, let's say, Sisters, Oregon, or Brothers, or Hines, or Burns, and said, well, 146.72 appears to be available, they would actually get in, the ORRC would actually look at, let's take a look at Idaho, let's take a look at Nevada, let's see if it's really available. And if it is, and they do a study and say there's the chance of them interfering with each other is really small, then they'd probably allow it. But you can't just go and put up a repeater anywhere you want. Now, there are certain frequencies in the published coordinations down in the 440 megahertz range where there are frequencies that are experimental. Remember I showed you on the map that there's a lot of open frequency down there? The bandwidths are really big. There's a lot of space on 440. There's a lot of repeaters there, but there's also a lot of space. Notice that 1.2 gigahertz, if you wanted to build a 1.2 gigahertz repeater, there's a lot of room. There's very few repeaters there. On 900 megahertz, there's very few repeaters. There are also very, very few users. So, you sort of have to take it, take it with a grain of salt as to where you're going to put it. But if you want to build an experimental repeater, you talk to ORRC or whoever your frequency coordinator is, and they'll say, okay, you have temporary authorization to put it here, run it for 6 months, and then you can move it somewhere else. Prove that it works. So that's a frequency coordinator. Frequency allocations and power limits. Okay, so now what we're going to do is everybody remembers, nope, not that page. Band chart. Okay, this band chart is super, super important. So if everyone has a copy of the band chart available to them, it's a good idea to take a look at it. It's a good idea to look at the band limits, the edges, 420 to 450, 50 to 54. It's not necessarily what you think it's going to be. You just have to memorize it. 144 to 148. You use it often enough, it becomes second nature. So the 6 meter band, is 50 to 54 megahertz. So obviously it's easy to pick which one falls between those. 146.52, that's between 144 and 148. That's in the 2 meter band. A technician class operator has phone privileges. Phone is another way of saying voice. You have voice privileges right there in that little blue hash on the 10 meter band. So where can single sideband phone be used in amateur bands above 50 megahertz? You look at the chart and you see that every band has a section which is light green. You can use single sideband on any one of those bands, at least somewhere. You can also use Morse code on any band, pretty much anywhere. However, you notice that there are these 2 little red segments here, or 3 little red segments. Those are designated as Morse code only. They're very small segments, but they do exist. So, which of the following segments are limited to CW only? You just have to memorize it. Now, one more interesting weird thing about this is that you notice this 1.25 meter band. This is the very lightly populated 222 band. It used to be 220 to 225. They don't even bother to show the fact that we also have 219 to 220. It is almost completely unused, but it has a special purpose, which is, and I quote, fixed digital message forwarding systems only. In other words, that's basically packet radio, point-to-point packet radio like bulletin board systems. That did not used to be separated out. What happened was that UPS a bunch of years ago came up with a communications method by which they were tracking packages and said, we'd like to put it somewhere. So they traded 2 megahertz in one place for 1 megahertz right next to it. And they took away 2 megahertz of ham radio space and gave us 1, but there's a gap. And they said the only thing you can now use it for is fixed digital message forwarding systems only. And again, that's just a I gotta memorize it thing. That's one of the oddball ones that will sometimes be on a test. It's another good reason to, and I'm going to put in my plug for the American Radio Relay League, because in addition to being the largest amateur radio organization in the United States, they're the only group of hams that has the ear of Congress and the FCC. So when the time comes and the telecom company, which has an infinite budget and 100 lawyers with infinite budgets, they go and they say, you know, those hams aren't using those frequencies. We'd like to use them, and we'll give you money. Like, here's a suitcase full of money. We'd like to give it to you. The only one sticking up for us, because, you know, hams are cheap. This is a hobby, right? It's a hobby that turns into an emergency thing sometimes. We have a purpose. The only one sticking up for us on Capitol Hill are the ARRL. So about 20% of hams are members of the ARRL. I don't know why it's as small as it is, because we all use it, and you know, we all use those frequencies, and the ARRL advocates for all the hams in front of Congress, whether they're members or not. That a lot of that money that you give when you become a member, in addition to like all the other stuff you get as for being a member, it also goes to lobbying. If you like the bands we use, lobbying is really important, and I strongly recommend joining. Anyway, that's my plug for the ARRL. I'm also the Oregon section manager, so if you have any complaints, I'm the person to complain to if you live in Oregon. Let's see, we talked about this. Why should you not set your transmit frequency exactly at the edge of a subband or an amateur band? Because some of it might spill over the side. You can also have inaccuracy in your dial. You know, the display might be off a little bit. You don't think that you're off frequency, but it turns out you are. As things warm up, your transmitter frequency can also drift. Components warm up, capacitors change in value slightly, and what you think was your dial frequency is now off by a kilohertz, and you're suddenly out of band and no one will talk to you. How are amateurs restricted in segments of bands where the amateur radio service is secondary? So I'm going to go back to this chart right here. On 2 meters, we are the primary user. Anybody else who shows up there is not supposed to be there. However, on 70 centimeters, which is a really big band, notice it's 30 megahertz wide, we are actually secondary users, which means that if, let's say, the military comes along, because they're the primary user, and says, you know, this is a shared space, but we really, really need you to get off there for the next 6 months, they are the bosses and we have to listen to them because we have a secondary, not primary allocation. So in addition to that, if we're cohabiting on a particular frequency, cohabitating, and we are interfering with them, they say, hey, we're running some pretty sensitive stuff here, you guys need to move, and it's being caused by your repeater, you might have to shut your repeater down temporarily. So just be aware that there's a big difference between primary and secondary allocations. Except for some specific restrictions, such as being within 100 miles of the Canadian border on the 70 centimeter band and a few things like that. Above 30 megahertz, you are allowed to run 1,500 watts of transmitter power. On the HF band, you're allowed 200 watts. 200 watts is still an immense amount of power for doing a lot of different things. And again, the reason why we are required to do licensing is, I'm going to show you this picture again. And Eileen, since now you're really good at decibels, right? You're
Yeah,
really good and comfortable with decibels. Okay, so we're going to run 1,000 watts, and we're going to now take this 1,000 watt transmitter, and we're going to feed it into a dish antenna, like John has, right? Because he has an Arden mesh dish. But now we're going to take this dish, and we're going to give it 30 dB of forward gain. Okay, so what is 30 dB? It's 10 plus 10 plus 10, right?
Right.
Okay, every time we have 10 dB, what do we do to our power? What is 10 dB equal to? Just write it down again. 10 dB is 10 times. 3 dB is double.
Oh yeah, 3 dB. Yeah.
Right?
So
So
Right.
so 30 is 10 plus 10 plus 10,
Plus
right?
10.
Okay.
Yes.
So we have 1,000 to start times, what does that first 10 dB get us? Come on, Eileen. It's 10 times.
Okay.
10 times. And
10,
the second one?
10,
And the third one?
10.
Which gives us 1 million watts effective radiated power in the forward direction. That is why we are in this class, because again, if you have an effective radiated power of 1 megawatt in the forward direction, you are allowed to do that, but you can really do a lot of damage with it. But you're allowed to do it. Okay. License classes. We are now able to get 3 different licenses: Technician, General, and Extra. There used to be a Novice. There used to be a Technician Plus, which was Technician plus 5 words a minute. The General exam used to be 13 words a minute. The Novice was 5 words a minute Morse code. The Extra was 20 words a minute. Then there was an Advanced class, which was 13 words a minute plus a long written exam. So this was simplified, I don't know, about 17, 20 years ago, something in there. So now there are 3 new available license classes. When you get your license, it is good for a period of 10 years. And the FCC used to mail out licenses. They don't anymore. It shows up in the license database. It's the same system that you went to get your FRN. So as soon as your license appears in the database, if it says active or valid or whichever one it is, you have a license. You can go and log in using your FRN and print out an official copy if you want for framing and putting it on your wall. You don't have to do that though. I do typically print one out. I carry it in my wallet. I throw it in my glove compartment. If I go traveling, I throw it in my suitcase with my equipment. You are allowed 1 station license grant. 1 license grant per person. What proves that the FCC has issued a license? It's in the database. Who can select a vanity call sign? That means any call sign you want. Any licensed amateur. Now, one thing that is true is that you have to pick, if you're going to do that, a license with a call sign that is appropriate for your license class. So the way that call signs are laid out is that there's always a number. The number does not have to follow the region of the country that you live in anymore. It used to, but it doesn't anymore. My wife is K3LUX, and K3LUX. 3 land is the East Coast, in particular the Mid-Atlantic, but she happened to like that call sign. So we applied for it. It's a little confusing if anyone hears it, but people get used to it. So another person in our club is K9JI. Her name is Joyce. So that was available, so she wanted it. And she got it. Now, one thing that is true is that there's always a number, and there's a letter, and letters afterwards. That we are only allowed to have 1 number, and you must have either 1 or 2 letters before and 1, 2, or 3 letters after. You're not allowed to get a call sign that is a 1 by 1. Those are special call signs. You can get a 2 by 1, a 1 by 2, a 1 by 3, a 2 by 2, a 2 by 3. I think that's all the combinations. Now, as a technician, you are allowed certain 1 by 3s and 2 by 3s. Any other call signs are reserved for extra class operators. So you want to get a better call sign that's shorter, you go keep upgrading. So for instance, if I want the call sign K7ABC, if it is not available, I have a technician class license. That's a 1 by 3. You're allowed to get it. If I see that W7AR is available, but I have a technician class license, I cannot apply for that. It will be rejected. So somebody will occasionally apply for a call sign that is, for instance, B1LLY because they think it's cute and their name is Bill. What's the problem with this call sign? Anyone?
There's
There's no B.
numbers.
There's a B. B is part of the Chinese allocation. So American call signs begin with a W, an N, or a K, or an AA through AL only. Those are all American call signs begin with W, N, K, or AA through AL, and that's it. So if you want one of these, you have to have an extra class license. You can always get a K, you can always get an N, you can always get a W. Okay. Moving right along. Okay, that's why they say which is a valid technician class call sign format. It's a 2x3. It's valid. The grace period if a license expires is 2 years. If your license has expired and is still in the grace period, you are not allowed to operate, but as soon as it shows up as being renewed in the database, you're good again. A club, the definition of a club is that it must be a group of hams with at least 4 members. If the FCC is unable to reach you by email, they can revoke your license. So make sure that you give them an email address that actually works. If they try to reach you, and they can't do it, they can actually pull your license. Which of the following locations can an FCC licensed amateur transmit from? Basically any part of the United States, which includes vessel or craft in international waters and being part of the United States. So if it's carrying a United States flag, you're allowed to transmit from it if the captain says that it is okay. If you happen to be the captain and it's your sailboat, you're good to go. How about as far as transmission of language that can be considered indecent or obscene? Prohibited, just like on any broadcast radio. No profane language. It can get you a fine. When are you allowed to transmit music? There's only one time that you're allowed to transmit music specifically for the sake of transmitting music. This came about when the astronauts used to be awakened by wake-up music on the space shuttle. They would broadcast, they would send music up to wake up the astronauts, and those transmissions would be retransmitted by NASA over the ham bands. So the FCC and NASA came up with a rule that said if we're retransmitting wake-up music to astronauts, you're allowed to retransmit it. That's the only time. We are not a broadcast band. We're not a music broadcast band. We're not FM radio. You're not allowed to do it. When is it possible to transmit messages encoded to obscure their meaning? Okay, now if we're sending information to a space station, which is in orbit, or radio-controlled craft, which might be, let's say, a big model airplane, we don't want those to be crashed. So we don't want somebody hijacking those and taking over and causing them to crash. So you can obscure their meanings. Now, interestingly, this does not mean, let's say that you're talking, this does not mean that it's just like scrambled voice. Scrambled voice is definitely not okay when you're just talking to each other, unless the other person has a descrambler and the method of encoding and decoding is publicly available. In other words, it's not private. If you and your friend have a secret language that uses all English words, this is not okay unless you tell everybody else what it means. That would actually be, it's not encryption, but it's obscuring the meaning. We are allowed to, the FCC responds to the International Telecommunications Union. That's a part of the United Nations that is essentially made up of all the member nations that have regulatory agencies for telecom. So if any country told the ITU, hey, we don't want those Americans talking to our hams, North Korea has actually not said this. We could conceivably talk to North Koreans if they managed to figure out how to license anyone, which they will not. The only situation that I know of where this was actually recently done was there was a group of hams from Italy who went to an island off the coast of Yemen, and they said, we're still at war, you can't talk to any Israeli stations. even though they're only, you know, a couple hundred, like 500, 600 miles apart. They could hear each other, but they weren't allowed to talk. In which of the following circumstances can the control operator? Okay, control operators. When can you receive money for operating a station? We are a non-commercial service, which means we do not receive money for anything we do. That's why we're allowed to operate for free. That's why we are allowed to basically get licensed for free. So, in the process of doing so, the only time that you're allowed to actually get paid to operate a station is if you are a teacher at a school and you're using it as part of your classroom instruction. When can you notify other hams of the availability of equipment for sale or trade? We are not allowed to sell stuff on the air unless it's once in a while and has something to do with ham radio. So we have swap nets. Those are fine. If you get on and say, hey, I own a furniture store and we're having a big sale, that's not fine. There are other means for that. Broadcasting, we don't broadcast. We might do one-way transmissions, but we do not broadcast. Broadcasting is meant for the general public. One-way transmission is transmissions that are only emanating from one place. We are not allowed to, again, broadcast. However, if let's say there's a news station that is covering a dam that's about to break, and the dam is starting to break, and there's a ham next to them, and the ham has access to a repeater, and they don't have a cell phone that works out there, you can actually help them get that information back to the broadcast station. Again, only during immediate safety of human life and protection of property. If you see immediate safety of human life or protection of property, that's when you're allowed to break the rules. What can we talk about? Communications incidental to the purposes of the amateur radio service and remarks of a personal character. Man, my back hurts. I've been sitting in this chair too damn long. Control operator and control types. There always has to be a control operator. An operator is the person who is responsible for what's happening. There always has to be one. Who is responsible? Who is responsible? That would be the station licensee, unless there is something else going on. For instance, if I am the trustee of a club station, the club station does not have a control operator assigned to it. I'm responsible for the station, but I'm not running the station. Who designates the control operator? That would be the licensee. So if, let's say, somebody comes over to my house and says, I want to operate, I say, okay, you're the control operator. They're using my station. I'm the licensee. They're using their call sign. So if something goes wrong, we are both responsible because it's my equipment and their license. If a repeater inadvertently retransmits somebody cursing on the air, the repeater, because it's automatic, is not responsible. The repeater owner is not responsible. It might be a good idea to shut it down, but they're not responsible. The originator of the offending information is responsible. What determines the transmitting frequency privileges of an amateur station? The class of the operator license held by the operator. This is all the stuff that's on this chart. And as a technician, you have access to everything 6 meters and above in frequency. Under normal conditions, can a technician class operator be the control operator of an extra class station? What do you think?
No.
If it's operating in an extra class band, the answer is no. So that is why most trustees, I'm the trustee of a station, most trustees are extra class operators, because then if somebody looks it up, you won't see a station that has a weird call sign that shouldn't be where it seems to be. So most trustees of club stations, for instance, are extra class operators. If you're allowed to transmit on an uplink frequency, you can work through a satellite, again, even if your signals come down somewhere else. The control point of a station, This right here, handheld radio, is this is an amateur radio station. This button is the control point because this is the position from which I switch it from receive to transmit. This is the control point. This would be known as local control because I am in local control and I am the control operator. So I am the control operator, this is the control point, and it's local. When I was running my station from my computer, that would be remote control, which means I indirectly operate the station from somewhere else over the internet. The advantage of being able to do this is, of course, that you can be somewhere else. There are a lot of people who do remote control from stations that are, let's say, on a hill on a really, really remote place in Maine, but they're sunning on the beach in Florida. Yes, we do that. They get to operate in contests just like they're sitting in the freezing cold in Maine or in Alaska or in the Yukon. There are big stations in all of those places that are remote controlled from other places. And they get to sit in Arizona or in the Caribbean or in Florida or something like that, enjoying, or Tahiti, and get to be in comfort drinking a Mai Tai or, something while they're operating a station that's freezing cold. Okay, control point is where the control operator function is performed. Remote control is operating a station over the internet. There is no, can a station ever operate with nobody in control? No, even an automatic controlled station, technically somebody is responsible for that station. So I'm in charge of a repeater. I don't listen to the repeater all the time. I can't be expected to, but if somebody tells me, hey, there's something weird going on, I'll do my best to go take a listen and shut it down and control it if I can. Okay, I believe this is the last part. We are in the last little subsection and we're only a couple of minutes late. Station identification, repeaters, third party, FCC inspection. You are required to transmit your call sign in the United States every 10 minutes and at the end. Notice you don't have to do it at the beginning. Most people like to hear themselves talk. Most people like their own call signs. So we usually give the call sign at the beginning, but you are not required to. You can just cut in and start talking, let people wonder who you are for 10 minutes, and then give your call sign. Most people don't do that, but you don't have to. When can you start transmitting without identifying? Only when transmitting to a model craft. If you have a Futaba transmitter, for instance, for your RC airplane, what you have to do is you are limited to 1 watt. It's typically on the 6 meter band, and you have to put your name, your call sign, and your name, call sign, and address on that box. When you're on an English subband, in a phone subband, you have to say your call sign in English. You can have a whole conversation in any other language, but you have to say in the United States your call sign in English. When I was operating in Chile, I was having conversations in English and Spanish. All the call signs had to be in Spanish though when it came time to identify. How do you identify? N7JI. Or in the background, I have a Morse code identifier, which is valid. Phonetic alphabet is encouraged because it eliminates ambiguity. Then there's something called a tactical call sign. Aid Station 1, Aid Station 2, Police Station Headquarters. So, how often do you have to use your own call sign? What's the rule, everybody?
At the end of the
Every 10 minutes and at the end. Even if you're identifying as race headquarters or Aid Station 1. You might say Aid Station 1 10 times in 10 minutes, but every 10 minutes you have to give your real call sign because that's not a real call sign. Self-assigned indicator. So stroke W3, slant W3, slash W3.
If you're sleeping at the door.
That basically means that you're saying that you are somewhere else. Or mobile, N7JI mobile. That means it's my call sign, but I'm in a moving car. You can use any of those. Third-party communications. Okay, so we were talking a little bit about phone patches. A phone patch is a combination of a radio with a telephone. So that can be a cell phone, like my daughter was in Atlanta. I took my cell phone. She was talking on that. I actually held the cell phone up to my radio and gave her the ability to patch herself in to a local net that we were running. It was air coupled between my phone and my radio, but people could understand her and she was able to check in. She is a third party, but she's a licensed third party. An unlicensed third party is somebody who doesn't have a license. You are allowed to pass messages on behalf of another person. You could also hand them the microphone so long as you're in charge and allow them to talk to another third party who is also not licensed, so long as the countries that you are working with, like inside the United States or US and Canada, permit it to be done. So this is how we do stuff at the museum. We have these little kids come up. We have them talk to other little kids that are somewhere else at a different museum, or we have them talk to other hams who are driving around town, and they all get to say hi. They're operating as third-party licensees. Similarly, during the Vietnam War, tens of thousands of phone patches were run because it was in the 60s and 70s, and there was no such thing as a cell phone. Long distance didn't really work very well. There were ham operators who would talk to stations in Vietnam and either pass messages on behalf of soldiers, or actually allow them to talk to people at home. And the station in the United States would connect their radio using wires to the phone line and dial up a phone number and actually get their loved ones on the phone. And they would be able to talk to them using a hybridization.
Basically, that's what I did when the tsunami hit Japan. I did phone patches back to the United States for the people that were on radio in Japan trying to contact loved ones here in the United States.
There you go. And phone patch still works, but it requires a landline or something like that, or some connection to a cell phone, and it's not as common as it used to be. On the other hand, you can buy an old Heathkit phone patch for almost no money now. You go to a ham fest, you can pick one up for $5. Okay, finally, if the FCC knocks on your door and says, we'd like to see your station, if you're licensed, you have to let them in to see it. This doesn't usually happen. The FCC has much bigger fish to fry. So what I'm going to bring up right now is FCC Part 97 and just show you what the FCC Part 97 looks like. The FCC Part 97 is the rules. This tells us what we are allowed to do and what we are not allowed to do. There is a lot of stuff in the FCC Part 97. Fortunately, there are electronic versions out there that are searchable, but basically everything that governs everything that you're allowed to do on the air and not allowed to do on the air is in these rules. Like frequency bands, modes of operation, emission types. There's a lot of stuff in here. You're not expected to read the whole thing. But the one thing that is kind of nice is notice this basis and purpose. Basis and purpose. There are 5 things that fall under the basis and purpose clause, which is right at the beginning. And I'll let everybody just take a look at that while we wind down and ask if there's anybody with any questions. I'm sure we've got some.
Yeah, if you're gonna go all the way up and get the extra class, okay, could you do like the second class and then do the extra class, like if you study for both of them?
Sure.
At the same time, is it too hard? Is the extra class really hard?
Extra is a hard exam.
So you kind of
I take that back. I take that back. If you have an engineering degree, the extra class is an easier exam.
Well,
but only if you have an engineering degree.
Yeah, no. So you'd probably want to do both of those separate.
Yeah, you go for the general. The general is actually very similar to the technician in a lot of ways. I mean, it's 35 questions. The material, there's a lot of overlap. What isn't overlap is the fact that you have all those additional bands and power limits and things like that. So the basic rules of ham radio are the rules. In a way, the technician exam is actually the hardest because you're getting used to the terminology. The general class exam adds some complexity as far as like, okay, what's a vacuum tube and what frequency bands can we use to do this particular mode. But there's still the basic stuff about electronics. There's still the basic things that you can and can't do on the radio. And they'll ask that again. When you get to the extra class exam, you have a lot of stuff that's now available to you as far as, you can be a volunteer examiner. You can launch your own satellite. Yes, you can launch your own satellite. You can be responsible for a lot more, a larger number of things as an extra class operator. And
I'm just worried about, getting out of my band. And I figured, well, if I get the extra, then I have use to all of it. So,
well, there are advantages to doing that. Number one, you can give exams, which I find to be incredibly rewarding. Number two, cool. You can not have to worry too much, like you said, about whether or not you're out of band. I mean, if you don't plan on doing HF, you don't really get that much. I mean, but if you like HF is where I spend, 95% of my time. I'm a DXer. I love going for long distance stuff. And I mean, that's the thing that interested me back when I was, 10 years old. And it still does. I still find it fascinating, and it's still what pulls me back in every day. The fact that, there's this stuff out there that I get to explore, and I never really know what's going to happen. I never really know what's going to happen on any given day.
Yeah, that's what I want to do. I want to do the long distance and everything.
So, and then the other thing is, if you travel, and I do travel for work quite a bit. I go overseas. I go to, I work in South America. I work in Europe. I was part of a de-expedition to Vanuatu for 10 days where we went and operated on an island for 10 days and made a gazillion contacts. When you go to another country, if you have let's say a technician class license, it is unclear until you talk to them what your privileges will be. If you have a United States extra class license, wherever you go in the world, you will get full privileges.
Oh, wow.
So whatever country you're in, you'll basically get the highest license class equivalent for the time that you're there. So you don't have to worry about, am I in band or out of band? You just know that, okay, well, it covers whatever their rules are. Their rules are probably a little different. Even between the U.S. and Canada, the rules are a little bit different. If you go to Hawaii, the rules are a little bit different because they're in a different zone. They have some different frequency allocations. Between the U.S. and Alaska, it's a little different. If you go to Guam or American Samoa, it's part of the United States, but it's also in another part of the world. So the frequency allocations are actually very different. But you still get the highest class license when you go there.
Oh, that's interesting.
Yeah. So
Thanks.
But at the same time, we have somebody in our club who's in her late 80s, and she had held a novice class for a while, and then this was from back in around 1960, and then she got her general class. And she and a couple other ladies in the club, they studied together as a group, and they spent a year getting ready for their extra class exams.
Wow.
So, it's not like, you got to do a crash course. If you operate, you will learn a lot by operating. If you go to club meetings, you get to know people and you have people to ask all those questions that you've got, things that you don't understand. And if you have other people to, who know the theory behind what you're studying, and you get to ask them, why is this the case? They'll go through it and show you exactly why that answer is what it is, even though it doesn't necessarily make sense to you.
Okay, great.
So, I mean, there are 760,000 roughly hams in the United States. And There are licensed people just about everywhere. If you go to, and I don't think we've done this yet, go to qrz.com or QRZ. If you sign up for your account to take control of your own call sign, and by the way, they have a program. See this Jumpstart program? That's to get this handheld radio down there, the QRZ Jumpstart. Assuming that they keep the program going, anyone who's been licensed for less than 6 months can apply for membership and get that radio as a package for like $22. It's actually quite a nice radio.
Hey Scott, throw this call sign in so they can get an example of what I've been hearing.
Yep.
It's Delta Kilo 1 November Juliet.
DK1NJ.
Yep. This gentleman was reaching out the other day, and I was picking him up on my local repeater here at the house.
That's cool. So you want to see? I was in Finland, and I was basically, it's winter time. I didn't really feel like doing anything, and I got in touch with one of the guys in the town where I was going to be staying, and I said, "Well, I know that we've got this. Club, which is OH3R, which is a museum station. Here's the museum station." And I knew that I could at least go there. And in town, there was OH3AC, which is the radio club of Lahti. I have pictures of that. This is from a very old building, one of the earliest AM radio stations in Finland. And they said, "Well, that's great. There's a contest going on. Why don't you get in touch with those guys?" I said, "Well, how do I get in touch with those guys?" Notice Elämäki Radio Club and OH5Z. Here we go. The OH5Z contest group. Can everybody see that picture?
Wow, great.
I was there. I have that picture on my phone. Not only do I have that picture on my phone, I actually got to operate from there. And if everybody has a minute, I'm going to pull this up because I'm pretty sure I have this right here. Finland. So this is just, I got in touch with these guys. I sent them a message on, stop share. I sent them a message on, hold on a sec. There we go. I sent them a message on WhatsApp, and the response was, "Hey, you're going to be nearby?" I said, "Yeah, I'm about, it's about it's 80 kilometer drive." And there's the picture, and there's me in front of it. And notice this was November, and I was freezing cold, but this is my favorite photo of all.
Wow,
that
that's
is
amazing.
a multi contest station that is using all those big antennas. And notice all this stuff on the wall. Do you know what those are?
Filters?
Those are filters. Yeah.
Those are soup on the wall.
Yeah. Oh yeah. And there's, because it's really cold, it was actually warm inside. But these two operators, this was a Morse code contest. They were actually operating on one band. These two guys were operating on a second band, and this guy here on the left is the pilot for the entire operation. And this picture right here is the station creator who just passed away last year, who used to be, part of this whole operation. And so once a year, these guys get together and they participate in the CQ Worldwide DXCW contest. And they said, "Well, why don't you go by and see if they need you to do anything, at least see the station." So he gave me a half-hour intro, and I got to operate right there in that chair for about 4 hours, doing nothing but high-speed Morse code, using those insanely huge antennas in Europe and these old, notice that's in Russian, Soviet-era amplifiers. That they got surplus.
Those are freaking awesome.
Isn't that? And this is just because, And this was me at the museum station. I got to do about 4.5 hours of operating from the museum station when I was there.
I love that old turn knob at the top of that photo.
Oh yeah. But this is the kind of stuff that, basically when I say, you can go as far as you want, you can go as far as you want. There are a lot of people who are real enthusiasts. And, you don't have to join, you don't have to be active, but there's a lot of opportunities if you want to be.
Cool.
So,
Hey, Scott, I live in Eugene. Can you drop when are the radio club meetings for you guys locally?
actually, not this Friday, but next Friday.
Okay,
It's the first Friday of the month.
cool. Okay.
And
And
if
then
you
I also,
if you go to valleyradioclub.org, we are I just put it in the chat, but I'll also put it up on the screen. We are an extremely now big and active radio club. And I'm this is actually probably the most active and well-rounded radio club I've ever been a member of. And I mean, I don't teach this class as technically a part of the club, but I'm certainly affiliated with the club. This call sign W7PXL, I'm the trustee of the station.
gotcha.
And if you look at our calendar, so here's December. There's something every day.
Wow.
I mean, there's literally something every day, which is great because, I mean, and we have a repeater that's, on top of a hill, on top of a mountain in the Coast Range at 3,500 feet. And, you could be anywhere within 50 miles with a handheld or a mobile radio and use that repeater and talk to everybody. It's also on Echolink. So you're traveling around the world, you can use it from wherever you are.
That's awesome.
And so, like for instance, I don't even know what that one is. Online tech class. That's the class that we're in right now. So like tonight, there's a board meeting going on. Ducks on the Air, Slow CodeNet. I lead that one. Ducks on the Air. That's the University of Oregon Club, which is loosely affiliated.
Boo.
Oh no, I'm the technical advisor for that.
I'm a beaver.
I also get involved with the Beaver Club, the W7OSU.
Mm-hmm.
Notice there's also Beavers on the Air. There's a club net for Oregon State.
Mm-hmm.
There's a 2-meter single sideband thing every Saturday. We have the Eugene Science Center open time on Saturdays, and then we have a halftime net during Ducks games. That actually is at physical halftime. Otherwise, it's at noon, and that's a simplex net. Then we have a statewide 6-meter net, and
I'll just stay away from the net.
This is just the university. This is just the Valley Radio Club. This is just that one club. Notice we have this Now What net. The Now What net was started by Barbara, Joyce, and Catherine, who just were incredibly nervous about getting on the air. And it started about 5 years ago. And it was created as oh my God, I got this license, I got this radio. Now what? That's literally
really cool.
That's literally the purpose of the net. It is the ultimate beginner's net. And then Tuesday night, we have our tech net, which is, heavy duty technical questions. Then John and friends run that digital radio net on Wednesdays, which is an analog net about digital radio. So, and then, and of course, anytime you want, you can hop on the repeater and use it. It's an open repeater. We don't require club membership, which is actually quite cheap. It's $12 a year. So
Nice.
Yeah.
Right on. Thank you.
Anyway, any other questions? I know
How much is ARRL membership?
ARRL. Okay, as of today, it's $49 a year. As of January 1st, I think it goes up to $59. So ARRL membership, there has been a big stink about ARRL membership because one thing that has happened over the last few years is that I'm just going to put this out in the open, is that publication costs, not actually to create a magazine, because if you've ever seen QST, that's the big glossy 100-page magazine that gets put out every month. Paper and ink have gone up drastically in cost. So what's happened is that it was that previously everybody, for as long as they had a license, would get a copy of the magazine every week, or sorry, every month. And they looked at the budgets and said, if we continue to do this, we're going to be bankrupt in 2 years. So the ARRL made a hard decision and said, well, we've got a digital platform. We actually have 4 magazines, 3 of which don't have that much circulation, but they're really cool. And one in particular is called QEX, which is an experimenter's magazine. It's the very technical one that's put out every other month. And then there's a beginners magazine called On the Air. And then there's another one called National Contest Journal. Those are the 4 publications. So what we'll do is we will trade a printed copy of the magazine for digital access to all 4 publications. And hopefully people will be happy. And if they want to pay another $25, we'll actually send them a printed copy for an entire year. And you would not believe the stink that has been raised as a result of that. It's like, I want my magazine. You're taking
because some people are set in their ways.
I know. But like I said, I'm the complaints department in the state of Oregon. So I 2/3. Actually, I'm gonna hit stop before I forget.